universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello, everybody. Welcome to Sky Tour Livestream. It is I, Marc D'Antonio, and I am here with Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
It's so nice to see you here, Daryl, and we're going to have fun tonight. And I got to say, the reason we're going to have some fun is because we have one of our Patreon supporters with us, Ronald. Hello, Ronald from ERRT Radio. How are you?
Hi, Mark, and hi, Daryl, and hello to YouTube chat. Thank you for having me tonight.
Okay, well, thank you for coming by. No, I'm just kidding. For those of you that don't know Ronald is a longtime pine bushaholic. He would actually drive 22 hours from Minnesota, where he lives.
25.
Oh, I'm sorry, 25 hours. Don't jip him out of those other 3 hours. And he would come out all the way to New York State and hang out at Bill Skywatcher's house, who is our producer for KGRA. And it's really wonderful. But Ronald's also a staunch supporter of SkyTour Livestream, a very higher-end Patreon supporter. And what he gets for the Patreon support is a free sky tour that's all his own. And tonight is Ronald's night. We should call it Ron's night. You know what I mean?
There you go.
Yeah. No, I don't. Man, I think we'll skip that part, but we will actually make sure everybody knows you're here. So this is good, and it's nice to have you with us, Ronald. So I am hopeful that people will also enjoy your being here with us. Now, tell everybody.
I hope so.
Tell everybody a little bit about where you live, which is the small town of Jeffers, Minnesota.
Correct. It is in the middle of the cornfield, and or cornfields, I should say. 2 hours from the Iowa state border, and like 2 hours from the South Dakota. So back down in the southwest corner of Minnesota, and it seems like we get like 4 seasons all at once, and it's really weird here, but yeah, I like it. It's not in the Twin Cities. I was in Minneapolis area for 17 years, and it was like there's a lot of crazy stuff up there, but that's a whole nother show.
That was
Anytime
enough. That was enough for you.
No, any big city is gonna have a lot more activity, of course.
Yes.
But I moved from a town called Brooklyn Center, a city called Brooklyn Center with 38,000 people in it, and that was a suburb of Minneapolis, right? And I
don't
moved
know.
to here. Yeah, Brooklyn Center is a suburb of Minneapolis, and between the Twin Cities, you got over 1 million people between those two cities. Okay, St. Paul and Minneapolis, okay?
Yeah.
And anyway, I live in Jeffers now with 349 people, and a couple people died, so I don't think we have that many now.
Ugh.
But anyway.
A couple people died. Yeah.
Yeah. So anyway,
Yeah.
I think the graveyard has more people than we have here that's alive. But anyway, I drive to town every now and then. I show the live videos on my YouTube channel, and I do that for kind of like insurance reasons. You know, if a deer runs out and hits me, I got it on insurance. You know, there it is. There's the video. You know, and of course, out here in the cornfields, anything can happen. Any weird stuff can happen, and so I want to have it on video if it does.
Well, you know, I know that
And,
in the cornfields, I mean, how many science fiction movies have you seen where in the cornfields, that's where the aliens come from? You know?
Yeah.
Of course, if you build a baseball field, then, you know,
or the children
shoeless
in the
Joe
corn.
Jackson shows up.
One time we had a state trooper. So I was with, my friend Mike had a minivan that quit right before we got to the house, and he went and walked to get my car out of the garage, and came back with my car. And I was talking to the state trooper, and I said, "Hey, did you ever see that movie Children of the Corn?" And we're right next to the cornfield.
Mm-hmm.
He didn't stay around too long. He left. 'Cause, you know, that the cop got it in that one, right? In the Children of the Corn movie. So yeah. Anyway, he didn't stay around too long. I thought that was kind of funny. So.
Yeah, that's I get it. Anyway, but in any case, Ronald, thank you so much for joining us. And like I said, this is your night. So I know you have a number of things you'd like to show. I have one up here. I use this for testing and focusing, so everybody gets the benefit of seeing. Bink. Measure 22. It's a beautiful globular cluster. It's about 9,700 light years away. Daryl said before we started that Measure 4, just a little bit west of Antares, the eye of the scorpion, heart of the scorpion, was the closest globular cluster to us, I think you said.
I'm sorry, I lost sound for a second. Repeat that.
I mentioned how you said before we started that the just west of Antares in Scorpius is Measure 4, which you said was the closest globular to us?
Yes.
Okay. I just wanted to make sure I relayed what you said correctly. And while we're waiting, the skies are pretty dark out there right now. It's 7:48. So we can start streaming earlier and earlier. I want to say hi to Tim F, who was first here. Hi, Tim F. Cyclone, a close second. Michael Hedrick, how you doing, Michael? PG, Petita. We know Petita. You met Petita, Ron.
Hey, hi PG and Woody. I always say PG
Yeah.
and Woody because
Yeah.
usually Woody is off on the side listening.
Yeah, and then let's see. We have Daisy and Zoe are with us. That's nice to see you guys.
Yeah, I know them.
Yeah. Okay, is Lane with you guys tonight? Let me know. And we have 24/7 live Arizona skies. How you doing? It's so nice to see you. I was watching the High Point Scientific stream today, and from Tucson, they actually had, I'm not sure where it was located, maybe on Mount Lemmon, they had one of the Lunt 60-millimeter solar telescopes aimed at the sun, looking at all the details. And I have to say, we might just add a Lunt system to our telescope, because that would make us able to see the sun. The hydrogen alpha filter is really unparalleled in its beauty and capability. And the only trouble is we have to make sure that it's either its own scope and not riding on top of another telescope, or if we have another telescope, we have to be able to shut that telescope. Now, I do have an automated closer and opener that I did develop with a stepper motor, and it works great. But the problem is that I did not install it. Right now, it's not installed because the telescope has got so much equipment on it. I didn't want to add another thing sticking off of it. So we reached the weight limit pretty much on that. So that said, we will probably take the next telescope, and we could mount it in the same location next to this telescope. So if we can't use the main telescope, we'll use this one during the day and maybe do solar work too, because
nice.
you should see the beautiful surface of the sun, and then the prominences that are coming off the edge. It's really, really pretty, really cool.
And that's what I wanted to mention as I was watching the one from Kerrville, Texas. All right, I was watching NASA stream, and they went from New Mexico to Texas.
Yep.
And on down with those. I finished watching it in Texas, and like, okay, I had enough of this. But anyway, it was in its totality, all right. And the interesting thing was they had a little thing come off the edge of the sun. You could see it.
Yeah, that's a prominence. That's called a prominence. Yeah.
Prominence. Yeah. Now, how far does that go out that we can actually see that? Isn't that like thousands of miles out from the edge of the sun?
Yes.
They're much larger than Earth.
Yeah, they are usually that one that was there today was just about maybe 3 Earth diameters, maybe 2 Earth diameters, or more off the sun, and that's just under the arc. At the arc,
that's incredible.
With the thickness of the arc, well, yeah, you could put 1 million Earths inside the sun. So we're talking a very large sphere. The sun's not a disk; it's a sphere. And just to finish saying hello, I want to say hello to who was it? Just saw it. Okay, Marco. Hey, Marco, how you doing? Michael Galea is with us. Michael Galea is with us. Judy M is with us. Papa Tom is with us. Hey there, Papa Tom. It's nice to see you as well. C&D Boy is with us. Good to see you too. Vince Giglio, how you doing? It's nice to see you as well.
I know everybody
and
in
he
chat.
says, Vince says, I found the park between Midland and Odessa, right along the middle of the path. So, that's pretty cool. So you must have said something earlier about what you saw. So that's pretty cool. All right, we're all focused up here. So Ronald, why don't you tell us what you want to see?
All right, the first one that came to mind, and I made sure it was visible, was the Andromeda Galaxy.
Yeah, no, we're not going to look at that. I'm just kidding.
Next time, that's next time, right?
No, we're going to look at it. I'm sure. No, that's good.
That'd be a funny comedy show. You'd always just say, no, that's next time. Next time.
Yeah, let me, sorry, so let's do one final save of this. This will be up in the database. Now, because I use this for focus and everything, this has been up here for quite a while, and we have a total. I've had this open for a while, letting it acclimate and get temperature, make the same outside as it is inside the building. So we've been exposing this for 46 minutes. So this is beautiful guiding right now. There's almost no wind at the moment. And this is the direction we look where things don't generally hold up well because some wind can hit us. So I've got 554 images stacked together right now to make this. So
Wow.
we're going to stack this right now.
I
I'm sorry, we're going
going
to save this. We're going to save this. And you will. Daryl, thank you for... I had thought that the distance on this was... Sound like I thought I read 97,000 light years. I'm like, no, that can't be right? And I wasn't sure of it myself. And then Daryl found the right number. I had too many decimal points in by a factor of 10, so it was actually 9,700, not 97,000. So thank you for that, Daryl.
Sure.
Okay.
I got to watch the eclipse with my own eyeballs. So there.
Yes, you did, because you were in Colorado. You got to see it.
The
It
whole
was
thing.
80% partial here, but
80.
it was cool. What I found really interesting, if from here in Colorado Springs, the moon passed somewhat south of the center line of the sun,
Yeah.
and the orientation of the crescent that the moon made the sun into. The orientation started about 7 or 8 o'clock, standing facing toward the sun. When I started watching, it was at about 7 or 8 o'clock. And interestingly, as it reached maximum and then past maximum, the orientation slowly rotated clockwise around the moon, that by the time I quit, the crescent was pointing straight up, 12 o'clock.
Wow, that was pretty cool. I know that Marianne, who's part of our Sky Tour live stream 501c3 nonprofit, Marianne looked at it. She was down in Benson, Arizona, and she was watching it there. And I was seeing it live on my phone because she was holding her glasses in front of the phone. And I could actually see it. It was really cool. And I snapped a shot of it. So it was pretty funny. Okay, Ronald, so you want the Andromeda Galaxy, huh?
Yep.
Oh, all
As much as you can fit on the screen.
Well, it only fits in just under half of it. So what we can do is a mosaic for you. And then what you get for your Patreon support with us is you get a fully processed, finished shot of the Andromeda Galaxy from us.
Oh, nice.
Yeah, I mean, only, and this one is going to be a personal shot for you. Okay, we've taken shots here. One more save of this, and one more save exactly as seen. And now we can get out of this. Finally, I've been watching this thing for almost an hour now. Well, people only see me when I open the building. They don't actually see... go away. They don't actually see all the work that goes in ahead of time. I'm in here long before that just to get everything up and running, get the temperatures all the same. Temperature is very important. This telescope has to be at the same temperature as the outside air. And when it's inside an enclosed building in the desert, it can get pretty warm in there. So you have to let it sit and acclimate. And right now, our camera is set to go to minus 20 Celsius on the center, and it's at minus 16.5. And that's a huge difference from the temperature in the building now, which is 23.7 degrees Celsius. That's a pretty big deal. All right, so let's go to our night vision mode. There's measure 22. And let's go to our nice, wonderful planetarium. And let's go to M31.
And then the interesting thing is that you spend 2 to 3 hours, weather permitting. You stay on the stream for another 3 hours for us.
Yeah.
So.
Okay, Andromeda is
Uh,
might be.
Michael H has a question. May I answer him quickly?
Yeah. What's the question?
Does the moon always catch the sun from our perspective in an eclipse, or does it ever look like the sun catches the moon and hides? Uh, Michael, the moon is moving west east in the sky about its own diameter every hour, so the moon overtakes the sun. During the eclipse today, the moon touched the west edge of the sun, and then it slowly crept eastward and left on the east side of the sun. So if you imagine, I mean, the sun is simultaneously moving east to west across the sky as the Earth rotates, but the moon itself, the moon has its own drive rate on a telescope drive because it's going faster than the sky is. So the moon always moves east to west. Therefore, it looks like it always catches up with and overtakes the sun. That's all. Thank you.
No, that's good. Thank you, Daryl.
Thank you. Yep.
All right, I'm going. Yeah, that's you, Ronald, snorting over there.
Oh, I'm sorry about that.
All right, so here is the core of the Andromeda Galaxy. This is Messier 32 that you talked about before. This is Messier 31. And if we go up a little higher,
I
right?
don't see it yet.
I still see Messier 22.
Yep.
How can that be? I'm streaming it. People are seeing this.
Huh.
I'm
That's what I was
literally.
wondering. It didn't change for me.
Oh, no? Okay, then let me.
Me neither.
Okay. Okay.
Well,
okay.
this looks nice.
Hang on. Hang on. Let me see what I can do here. We got to figure something out here. That's probably. Let's see. Okay, technical glitch, folks. 1 second. Let me see if I can. I want to stop sharing the screen and then reshare the screen.
Well, now you got night vision mode, and I think you're looking at.
I see it now, yes.
Are you watching through YouTube, though, or are you watching?
Oh, no,
On
I'm watching
Skype.
on Skype.
So
I'm on
why
Skype.
why did it take time?
I don't know, but it's on Andromeda now, and it's at
Yeah.
green night vision screen.
Okay, so if I was trying to show if I keep going up now, all right, you should see it moving as I go up now.
Yes.
Okay, so there is Messier 110 right there. Okay, Messier 110 is an elliptical galaxy that's attached, I should say, it's a satellite galaxy of Messier 31, which is the Andromeda Galaxy. And this is an elliptical galaxy, and this one's an elliptical galaxy down here. And they generally are gas and dust free. But this actually has some dust lanes in it, which we'll see after in the second photo. So I'm going to come back down, and it's going to end up getting out of the shot for a minute because I want to capture just the lower part of Andromeda. Andromeda is a pretty big galaxy, so we want to get this nucleus up as high as we can. All right, and by putting the nucleus up high, we catch the most we can of the Andromeda Galaxy, which goes down here and out a little bit. So let's move a little to the west now, and we'll probably right there. That's going to be good. Okay. So now you watch this, and this is going to start searching for our guide star. All right. So when it starts showing numbers like it is now, we're going to start guiding. If you watch the numbers, they should stay in the 0 point something. If they go to 1, that's okay. If it goes to 2 or 3, then it's not going to be good. So between 1 and 2, we can handle. If it jumps up to 3, 4, or 6 or 7 as it has, it means there's wind. All right. So right now we're good. So what we're going to do is we're going to set a exposure time over here. We're going to say 25 seconds. And we're going to be at 200 gain, a little bit higher than we should be, but lower than what I normally use. The camera's noise level is best at 100 gain, but we use 200 because I'm greedy and I want to capture all that I can, all the data I can. All right, so 25 seconds, and then I'll get out of night vision mode. And now over on the right side, you'll see the progress bar over there. And so now what we'll do is we'll go into the live stack, and you'll see Measure 22 from last time. And we can clear this video buffer. All right. And for those who are joining us for the first time perhaps and lurking, this is the telescope control. This is the telescope computer. Those are the telescope images in the building out there. This is the camera control over here, the focus control. And this is our stack control. It's where we stack images together. Okay. Now, this image here is not color corrected yet. See this we have down here? We have red, we have green, and blue curves. Notice they're not aligned with each other. They're not. The red is more dominant, so the red is a bigger part of the overall white average curve than it should be. So to correct that, we can simply correct the color, and just like that, we'll get a color corrected view, which is this. And as you can see, it shows things a lot better. And right now, we're seeing the Andromeda Galaxy, and you can see Measure 32 here. You can see the dark lanes in this galaxy that's 2.5 plus million light years away. And then you see these blue objects in here. These are blue clusters of hot young stars. And this is part of the disk of the Andromeda Galaxy. It's a spiral, kind of on edge, kind of like this to us, right? So you're seeing it kind of along the spiral, like a disk that's been kind of flattened toward us, laying more on its side toward us. Not seeing it edge on, but kind of almost. So this is the Andromeda Galaxy from this perspective. And now what we do is we'll try to increase the contrast and show you even better. See that, Ronald? There you go.
That looks nice. Yeah.
Yeah, and we will. I can actually do one better. Let's get the stacking screen out of the way, and let's move the telescope out of the way. And now let's just do this. Let's just have this on the screen so people can see the entire view. All right, and of course we can move up and down here, so you can see this is really the meat and potatoes of a galaxy, is its spiral arms. Look at this beautiful band of blue. This band of blue is hot young stars that are formed in the disk. Now, don't immediately think of life, because when you see hot blue stars, they generally give off a lot of ultraviolet light, which to carbon-based life like us, kind of dangerous. Right? We would rather be in a very quiescent part of the universe where the star is stable and long-lived. And so in this particular case, we are noticing this galaxy as it was 2.5 or so million years ago, because that's how long it took the light to get here. And so these hot young stars are probably, some of them may already have gone supernova, because they may have already existed for a couple million years, and they would then have, lived their lives and gone supernova, littering the interstellar medium with all kinds of more dark dust, like you see here. All this dust came from supernova explosions over the past several billion years, and this is the stuff from which you come. This is where it all starts. All right. Stars are one thing. They're made of hydrogen, and they make some elements in our periodic table. But it's the dark nebulae that are made during supernovae, and when a star gets older and puffs off its outer layers, it sometimes makes molecules of dust, all right, soot at some points. And that's carbon-based stuff.
Now, here's a question for you.
No, you're going to ask a question?
Okay. in size comparison to the Milky Way,
Yeah.
how big is the Andromeda Galaxy itself? Not the companion galaxies, but
Well,
just the main galaxy.
we have about 100 billion stars in our galaxy. That's an estimate. It could be as high as 400 billion. However, the Andromeda Galaxy is more than twice as large as our galaxy. In fact, it could have up to 1 trillion stars in it. Okay.
Wow.
Yeah. That's basically 1,000 billion. That's a lot. And so when we have 100 billion, it's got 10 times more stars in it than we do. So it's a fairly large galaxy as galaxies go, but not the biggest. There are bigger galaxies out there. This one just happens to be one of the closest to us.
Now another question
Yeah.
is, who's older, the Milky Way galaxy or Andromeda?
Oh, I would say that the galaxies are probably around the same age. They've kind of formed all together in the local group. This galaxy formed with us along with the Triangulum galaxy. So we all formed in the same local region of space. There might be a difference of a few, maybe 100 million years. I don't know for sure, of course. But they formed in the same relative location, and we're still in a cluster with the local group of galaxies, which are over 30 other galaxies that are kind of in our what's called local group. And the ones that are closest to us are galaxies that probably formed around the same time that we did. Andromeda has been steadily getting closer to us, and in about 2 or 3 billion years, it's going to merge with our Milky Way, and we're going to be part of this galaxy. We're going to become part of that galaxy. And that's interesting, yeah.
I won't be here then.
Well, how do you know? You could just start over and say, oh no, we're going to do this all over again?
Right.
All right, so let me just kind of drop the noise a little bit. There we go. So now you can actually see more detail. And actually, to see it even better, I'm going to turn on an enhancement as well. So I'll come over to the enhancement tab and turn on my unsharp mask, which I do not have very high, and you watch the detail jump. All right, so now you can see more detail in here. See that?
I like that. Yeah.
This is
I don't
pretty.
remember getting that. Yeah, I don't remember that with 35 millimeter film.
Yeah, I know it was there, but yeah. Hey, Daryl, this is pretty tonight, don't you think?
Sure.
Yep.
So what region would have life in that galaxy? Would it be where the blue stars are, or no?
Yeah,
not our.
Yeah, as I said before, these blue stars are regions where there's hot young stars here, and they're currently not a region that's conducive to life, most likely because of the high ultraviolet radiation, if the life is carbon-based. And I say if. I'm a carbon bigot. I mean, I am. Sorry. So I believe that carbon is probably the source of most, if not all, of the life in the galaxy universe. And the reason has to do with the elemental abundance of carbon in the universe, the flexibility of carbon, and what it can do. Carbon, as I've mentioned many times, can make and break more bonds with more things than any other element in the entire periodic table. It is simply the granddaddy of all elements, the most capable of all. And so that's something that really has to be driven home, is that we actually have to consider that this is not a galaxy. Carbon is not an element that is to be trifled with. It has a massive impact on the universe and the life that is created by it. And from it, I mean, this is really how it works, without a doubt.
Interesting. And then, how many stars are like in the nucleus of that, like right at the center? Like you got the.
I mean, in
one. Here? Yeah. Like
I'm sure there's several million stars in this region. I can't tell you how many. I actually don't know. Maybe Daryl does. I don't know if there's any star counts that were done in this region. Do you have any idea, Daryl?
No, I don't. I would guess billions.
Yeah.
I mean,
Wow.
if there's a trillion stars in Andromeda, you're easily looking at many billions of stars in the nucleus. There's some talk nowadays that Andromeda has a double nucleus. They think it may have been two supermassive black holes merged or something of the sort in the nucleus. That's one reason it's so oblong looking.
You got to be reading my mind, 'cause that's what I was going to ask next. So you answered my question. That's pretty good.
Well, I think that's very important, though, right? I mean, it is very, very interesting to think about that. But as far as what we got going on there, unless somebody does a formal star count, we don't really know. But as Daryl said, and I said, it's very possible that we've got, millions or billions of stars just in the nucleus. After all, they are more closer together in the nucleus than they are in the spiral arms. But you're looking at a vast cloud of many stars out here, too. And so together, they all add up to 1 trillion, probably.
Wow.
David Schmidt asked the question, the two dark bands running from 12 o'clock down close to 3 o'clock, are those empty sections or dark dust? And I said they're dark dust and gas. I mean,
yeah,
that's the birthing grounds, so to speak.
Yeah, so let's zoom in on that for you, David Schmidt. So these are what we call dark lanes in a galaxy, and they are, as Daryl said, made of dark dust. That dust is made, I've mentioned a number of times, this dust is made of carbon, generally, carbon and other elements that form molecules together. Much of the interstellar dust can be characterized as carbon-carbon molecules. Carbon is an atom that has on its outside orbital, okay, it has 4 electrons that can bond with other things. So it very easily bonds with other carbon atoms. So we get carbon, diatomic molecules of carbon, okay, C2, and you'll see carbon-carbon a lot. And then they merge together with other carbon-carbon molecules, form these massive supermolecules, and then they attract ices, methanol ice, formaldehyde, ammonia ices, water ice, carbon dioxide ice, and more ices, and those become the fertile building blocks, okay, of life, because you get complex hydrocarbons that are formed there. You get a lot of chemistry going on the surface of these dust particles, and when a star comes along and heats them up, those ices sublimate, releasing all those elements and compounds into the stellar nebula, and then so that's the stuff that planet building, begins with. Really, really an amazing process. And we believe in the nebular hypothesis, which is how the sun formed. Now, as an example, see that right there? Okay, that thing right there. Okay, let me go over to it. This guy right here, that is like an Orion nebula. That's an H2 region, an excited hydrogen region that's actually a stellar nursery location in this galaxy 2.5 million light years away. So we're seeing it here, and so at that size, for that size of the galaxy, it might be something the size of the Orion Nebula, maybe a little bigger. All right, and there's so many of those when you go through here. You look through the Andromeda Galaxy, and there's many of them all over the place. And here, we see some right here. Okay, there's a little tail there. That's actually a nebula down here, a stellar nursery. And I could just float out here all night long.
Is it fair to say the dark areas in places become the red areas, which in turn become the blue areas, and then the blue areas spread out their stuff to make more dark areas.
Interesting way to put it, but I know exactly what you're saying, and that sounds right, Daryl.
Yeah.
That sounds like a really good analogy. So
So the dark lanes were the blue areas, and at one point.
well, no, the dark lanes would ultimately spawn more stars, which might spawn stellar nurseries, which are the red areas Daryl's talking about. Okay.
Okay. I get
And
it.
then those red areas might spawn young hot stars, which are blue, but then the dust itself doesn't ionize, but what the dust does is scatter blue light. And there's an example of that happening right here in the Andromeda Galaxy. This is dark dust, and there's some hot stars there undoubtedly, but there's stars there that are too dim for us to see, but it's not too dim for the dust to scatter the blue component of their light. Blue light is very, very high frequency relative to red light, which is very long frequency. Blue light's short frequency, likes to scatter and jitter all over the place. So what we see is the starlight will come in, strike these particles in here, and the next thing you know, these particles, they absorb the blue light and send it out in many directions. So that's why you see it as blue. And any remaining light coming to us from that star is going to appear to be redder than normal because the blue light is being taken out of it. You see? So that's kind of how this works. So Daryl is right to say that the dark areas become red areas, and then they become stellar nurseries. That's the red areas. And then when the stars go supernova, okay, or well, I should say when there's other stars in the area that aren't quite hot enough to ionize the hydrogen, they might be have their light dispersed and scattered by this dust, and so they become blue nebulae like this one, and then ultimately they become dark nebulae again. So it's like a ongoing cycle of life and potential life in the universe. I can see that as we went from Messier 22 to here, we actually we had something called mirror flop happen. So our focus is slightly off. It's a tad bit soft. So we'll focus it in a bit. But take a look now at your blue stars here. Look at all this massive cloud of blue hot stars. That's incredible. And
that
there's
same
more.
color blue. Yeah. I can see that same color blue is like the Pleiades star cluster. Kind of like that shade of blue.
That's correct, and that means a couple things. It means that the stars are hot, and it means that the stars may be O or B stars. So A stars are white. If they're blue, they're O or they're B stars. O stars are the bluest there are, and because the blue is the hottest color, and the next star type down is a B star. Those are also hot, but they're not as hot as O stars. O stars are hotter.
Okay.
Yeah.
Now our sun is M, correct?
No,
G.
that's correct.
Oh, I was close. So.
Oh yeah, it's like you were in the OBAFGKM scale. Yeah.
I was only 4 letters away. Right?
You're only
Yeah.
and just a few thousand degrees in temperature, but don't worry about
There
it,
you go.
Ronald. You're not expected to be you're not expected to be an astronomer.
What does G stand for the type?
It doesn't have it doesn't stand for anything, but the G.
Oh,
type-
Amanda always says guy or girl.
I see. In the moniker, yeah, it's in the metaphor to remember all the letters. All you have to remember is OBA, fine girl, kiss me. That's the metaphor. And Amanda would say, change the girl to a guy, and you can remember the letters.
Yeah.
Yeah, that's how it works.
All right, good deal.
It's a mnemonic. I can't even
Mnemonic.
say it.
I know, right? It's a mnemonic.
There you go.
Yeah.
All right.
Sam S. has a question.
Okay.
Is it known whether the stars and galactic nuclei have an average spread between them? Not
Depends
sure
on the
I
galaxy.
understand your question, Sam.
Distance
When you're
apart.
in the nuclei, it's like you're downtown in a big city. There's more stars and they're closer together. An average spread? I'm not sure how to quantify that.
I think it depends on the galaxy.
Yeah.
But it is an interesting question that Sam poses to us, isn't it? Let's have Ronald answer that. Ronald, can you please take this for Sam?
Well, I lived in a big city for 17 years.
That's why I was
in
saying
and
it.
around. And
Yeah.
So, as I was downtown with a few hundred, or let's go to the baseball field, okay? I was at a baseball game once. Had 38,000 people there as one person.
Mm-hmm.
But yet we had 38,000 people in the stands. That was pretty damn crazy.
Yeah, I can imagine.
Anyway, in any case, the interesting thing about that is that we're all one person, but yet there were 38,000 watching the ball game.
Wow.
You know, and when you look at the next person next to you and you're thinking, what is that guy doing? What is he doing? What are they doing? You know, what are they thinking? You know, and then we're all enjoying the game though at the same time. We're not arguing about politics. We're not talking about nothing else. We're just watching the game.
Yeah.
And that was an interesting thing about that. Of course, I don't recommend that for anybody who don't like crowds. Now, I know when I went to Pine Bush the last few years, except for the one that we had a tornado, but the other years that we've gone, we've had over, I think Bill said we had over like 5,000 people attend, something like that.
Yeah.
I don't know. Over the weekend, you know. So that's pretty darn amazing, just in that little setting with that little event there. You know, you think of it as being a little event, but then when you realize how many people are actually there, and you're one of them that are there.
Yeah, that's right.
So,
Sam, to your point, you've doubtless seen the video. It's on YouTube of the neighborhood of Sagittarius A star, this black hole in the center of our galaxy. And if you watch it, you see all the other stars in the area. They're all looping around the black hole. Some are real close and tight and really tight ellipses, and some are farther out. It's a very busy place.
Yeah.
And there's a lot of stars in the center. As Marc said, it does vary depending on the type of star. There are tightly wound galaxies and there are very loosely wound galaxies. Large nuclei and small nuclei. Some hardly appear to have a nucleus at all. So it varies.
Yeah. I'd like to say hi to JSCO, Cosmic Rays here. And let's see. There was a question. James Hyatt, how you doing? Good to see you. And Alice Pooper's with us. Nice to see you as well. Many of us are fresh off watching the eclipse, and now you're watching a stream where we bring you the universe live, which is great. And Cosmic Rays offering up a bunch of really interesting information, which is always very helpful. Suzette Bavier, how are you? Nice to see you. She's been in once in a while, and it's nice to see you come back. Let's see, David Schmidt, nice to see you as well. I hope that, David, we were supposed to teach a class for you, and still willing to do that. Still willing to do that. We have to set that up.
I remember you were talking about that.
Yeah.
So I had a question about the eclipse today. If the moon, what's the closest point to the Earth that the moon could be, and what would that look like for an eclipse? You know what I'm saying?
No.
Okay. Well, see, the moon has to be at a certain point to get that dramatic look of an eclipse. Okay, has to be so close and just the right distance in order for it to be big enough to do what it's supposed to do, right?
Oh, okay. I know
The
what you're
moon
saying.
has to be
It
close
has to
enough.
be. It has to do with precession of the nodes of the moon's orbit. Its ellipse and its ellipse. Daryl's about to explain it, I think.
Yeah, thank you.
Go ahead.
No, I was going to say, the moon's orbit's an ellipse, right? But it's not an ellipse. It's always, has the shortest distance in the same spot. That varies. If you look at my hand, you can't really see that though. But the shortest distance, it kind of precesses around the Earth. And if that shortest distance corresponds with the point where it's crossing the Earth's orbit, and it also corresponds to where there's a new moon as seen from the Earth, then the moon will be seen in front of the sun. But because it's inclined about 5 degrees to the plane of the Earth-Sun orbit, the moon can go around us many, many times without causing an eclipse. Otherwise, if it was all the same and all regular, we'd have an eclipse every single month, but we don't. Okay, and that's precisely because of the fact that the moon's orbit's slightly tilted, and we also, to see a total solar eclipse where it blocks the whole sun, or an annular like today, that depends on which part of the elliptical path is at that point where it's between us and the sun. If it's a farther one, then the sun is going to still show as a ring of fire like today. If it's the closer one, then the moon is closer and fills the whole view and covers the sun.
Okay.
And the sun is a factor also because the Earth's orbit around the sun is also an ellipse.
Mm-hmm.
So sometimes they're closer to the sun, sometimes they're farther. You can get different setups, different instances where the sun is close, the moon is far, and you get an annular eclipse, maybe an especially annular eclipse. And you can get a moon is close and the sun is far, very much so, where you not only get a total eclipse, but you get a very long total eclipse.
That's
The total eclipse I saw back in 2017, totality only lasted about a minute and a half from my location.
Rip off.
I was north of Scottsbluff, Nebraska. And the big eclipse next year, I think they're saying on the order of maybe as much as 4 minutes totality. And
Wow.
I think the most totality you could have is like 7 minutes or so, something like that. In ideal circumstances, either way.
That's pretty cool, though. That's really cool. Thank you, Daryl.
Yeah, thank you.
Okay, so what we're going to do now, Ronald, is we're going to redock our stack here, right? And we're going to also bring back the telescope. So we're going to move this over. Okay. And there we go. And now what we're going to do is label this. This is our label location. We're going to put the label in here. And it'll be M31 Andromeda Galaxy. All right. And this will be your photo that we will process for you. We're going to go do the other side of the galaxy here soon, and you'll see more of these hydrogen emission regions here as well. So it's actually pretty cool. So let's save this.
Okay.
Okay, so that's on its way up to the server right now.
Yeah, I was looking at that on Stellarium, and that looked really nice on Stellarium.
Yeah, this our view of the Andromeda Galaxy can really be enhanced quite well. I think it's going to look really nice. So now let's go back to our night vision mode, as I call it, because this gives us the ability to just hunt around, see what we want to look at. But in this case, we know exactly what we're going to. We're going to actually head up north, and we're going to head to the east. So we're going to hit north here and move up. We're moving the telescope up, and you're going to see Measure 110 come into view. All right.
So you're going to be moving the nucleus from upper left to bottom right.
That is correct. But I want to get Measure 110 in there as well, so I might not. Well, you know what? We can do 110 separately. All right.
Yeah, that'd be fine. Yeah.
Yeah. Okay. So let's bring this down. You can see where the telescope's pointing right here. It's actually pointing over into the northeast. And so there we go. So now let's move eastward. All right. And we have our spider web in our building here that's actually acting as our wonderful little weather vane. I mentioned last stream we're going to end up getting a weather station, and so we'll all have access to the weather out there, all of you as well, because we're going to make it available to everybody.
Oh, good.
Yeah, I might put a display on the screen showing all the details.
What the wind is and all that.
Yeah, where the nearest spider is.
Yeah.
That's for Bill, New York Skywatcher, because Bill, he's afraid of spiders, so we want to make sure we know where they are.
Then we'll make sure we'll flash that tarantula on the screen that Marianne had as a pet.
It wasn't a pet. It sent her screaming out of the observatory while I was on the phone. I thought something really bad had happened. Okay, we're going to do a focus run here, guys. Just, you see the donuts? I've defocused this. And let's make sure we can capture enough stars. There's too few. 7, 6. Okay, that's enough to start. And now we're going to start focusing. And you'll see the squares appear. Those are our data points that it's going to capture. And it's capturing the entire frame, by the way. It's not just doing just that one region. So it's going to go into a perfect focus. And what we're going to do, Ronald, is we're going to then take this image and we're going to merge it. We're going to mosaic it with the other image. And that's and then we're going to fully process that combined image. And when that's going to give us a beautiful Andromeda Galaxy in its entirety, and then we'll deliver you through a Dropbox or something like that, a very, very high-res image that can't be emailed. It's going to be way too big for that.
Yeah. But then I can have it printed if I want it on a glossy,
yes.
like,
you can
what do you call those?
Yeah.
A certain kind of print that you're going to get made where no frame, you just have a
canvas. You can actually have it printed on a canvas, yeah.
Yeah.
So we'll see.
Giclée, a gallery print.
Yeah, there you go.
Oh, is that what they call it? I don't know. I didn't know the term.
Yeah.
Thanks.
Well, I want it I don't want it like a poster. I want it like a real picture.
Oh, yeah. Well, that's
well,
what we have at our Sky Tour Gallery out in Mesa, Arizona.
That's what we did as part of my job at work. We printed large canvases called Giclée, Giclee.
That's why you know that. Okay, that's cool.
And the type of canvas without a frame on it is called a gallery print.
So what do they run for? Not a huge one, but a decent size. What are you looking at for a print that's of good quality?
$1 million. No.
Come on down.
I know. It's going to vary, Ronald, depending on where you go and who you get it done by. There's no real average cost that you can come up with just off the top of your head.
Oh, okay. All right.
I got to say hi to the Alabama Constitutional Crusader. Hi there. How you doing? And Creamers, what's up? I saw you guys join us. Thank you. Cindy Murphy, hello. Really, really cool to have you guys with us. And I'm now going to start the exposure here because we're going very well here. All right, and this we're going to do the same length of time, so 25 seconds. And off we go into the wild blue yonder. Okay. And we'll go back into our live stack again here. And this is the last picture we did. And now what we're doing is we're going to do from here up further, up to the upper left, to get the rest of the picture. So that first one is coming in. Now this new camera is really really proving that it's worth its weight.
What is the difference between besides the old one had some technical issues, but in quality-wise, what is the difference between the two?
This one is almost twice the resolution as the previous,
Oh,
for one thing. And the second thing is that it's also showing us a more magnified field by a little bit. So we've magnified the field, and the field that's now bigger is also almost twice as resolved. So we have a lot more pixels building the image than before. It really is effectively twice the resolution.
all
When
right.
you consider
good.
it's a bigger field and tighter pixels. It's actually one of the more sensitive ZWO cameras out there.
And well worth the price it is.
Yes.
At,
yes.
So,
But I'll tell you this. Now, the other thing is, the other camera we had is going to go back to ZWO for servicing. And then we're going to take, and in place of that camera, which will probably go on the East Coast telescope when we put that back, which is right behind me here in the office, we're also going to get a new camera for that telescope that we're putting in Arizona, the second one out there, which will really be the third installation. And that one's going to do both guiding and imaging in the same camera. Basically,
nice.
it's twice as expensive for the camera. However, it would actually cost more for us to get the additional equipment we would need to guide separately and image separately to actually guide. So it might
so
be
then
twice as expensive, but
yeah.
it's going to be just about half the cost of what it would actually be to do it the other way.
Before we were talking about it, we were talking about the guide scope, which that will be in the camera now. What you're saying, right?
It is built into the camera, yeah.
Wow. Okay, so that makes sense.
Yeah.
So
However,
you're putting the
However, I will say this. That camera is not suitable for this telescope because I actually did the calculation and we want to get the number of arc seconds per pixel, basically. Right?
okay.
And the smaller the number can be, the better you're going to see. Right? But because the pixel size on that other camera is larger, okay, this pixel size on this camera is like 2.7 micrometers, okay, microns. And so that's a really relatively small, in fact, pixel size. But on this other camera, it's going to be like 3.76 microns. And that it would actually not be very efficient or good on this particular telescope system. So what we're doing now is the best way to do this. And when we do it on the other scope, that new camera will show us the sky as best as it can possibly be shown with that new camera setup, because we're not going to have a wide angle system. The new system is going to be able to take a picture of just this region of the galaxy, for instance. Okay, so we're going to be able to zoom in and we'll have a wide angle field, and at the same time you'll be able to see a close up of some of the details of really cool areas in the galaxy.
Oh.
Yeah.
Okay.
Yeah.
I can't wait till you get that new one up and running. I'll be excited to see that.
Yeah, I mean, the only thing that's the holdup right now is getting the enclosure built out there. And I'll be visiting it. I'll be out there from November 2nd to November 9th, working on teaching in the desert. I'm teaching a boot camp out there, but I'm gonna be going out to the observatory site and doing a couple things. Number one, and this is something Daryl could understand, I'm going to do a master dark frame at our typical exposure, which is 30 seconds, and a typical gain, which is going to be 200. And that master dark frame is going to actually be put in down here Okay, right now I have a master flat that I'm putting in, and I know some of you may not know what that is, and I'll explain it. And right now there's no master dark. The dark frame, see, every instrument has its own quirks and its own artifacts that get stuck into the system. This one, this particular camera, you see there's a little glow right here? I don't know if you can see that, but there's a little bit of a glow right here. It'll become more obvious shortly. In fact, if I do this, it might become very obvious. You can see it now. You see this white glow?
Oh, yeah. Yeah.
That white glow is called amplifier noise. And that's something that a dark frame will remove, because it occurs whether there's signal coming in with stars and galaxies or not. So on a dark frame where there's no stars, and you're just going to get all the idiosyncrasies of the camera, and you subtract that out by frame by frame by frame. Also, we're getting an additional terabyte of storage, and so we're going to be able to now, instead of just save none here, now we're going to be able to come in and say save all, which is going to actually save the actual raw files, so that even if there's wind, we can go back, take a big stack, get an idea what the stack looks like. You'll see those raw stacks. This is a raw stack we're looking at right now. We just happen to have a good clear night with a good seeing and good transparency and very little wind. And what it'll do for us is it'll allow us to go back and stack privately all the frames where the wind wasn't that bad. And we'll be able to align and stack all those. And if there were a couple frames that were bad, we can throw them out. When we do it this way, a dynamic stack, well, they get stacked no matter what. All right? So I've got to keep watching this.
Then you pick the best stacks, or best ones.
That's right. Exactly right. Yeah.
I like that.
Mark, could you excuse me, please?
Okay.
On the new system, what is that going to be? What kind of scope?
It's going to be a Celestron 11. So it's an inch larger than this one. But we're not going to run it at f2, which is what this is. f2 is photographically fast. So we're going to be able to see things like this, but we're going to be using special filters in order to do it.
Mm-hmm.
Which we're doing now, but we're going to be using it.
And then what kind
type.
of...
we're going to have a filter wheel so we can roll through different sets of filters.
And then what kind of mount is it?
We're using an equatorial mount that's going to be known as a CGX mount.
11 or something like that?
Well,
Right.
for the 11, the Celestron 11, it's going to have a CGX mount. It's not going to be a fork mount like this telescope. See, this telescope has two forks. There's one, and the other one is right here. Okay, the other, and then it goes down to a U shape and goes up there. That's how some of the larger telescopes are built these days in the observatories.
Yeah.
But we're going to go with a German equatorial mount setup, and that will be really good, because then we won't have any danger of the telescope colliding with the mount. You can actually, if this thing were to go down, or somebody told the telescope to go down, it could collide with this bottom bar here, and that
Could be
could
bad.
well, it could do a little damage. So we don't want that to happen. All right, we've stacked 20 here, Ronald. We're gonna keep going. There's our white. There's that white stuff I was telling you about.
That reminds me of the old flat, when you had this old... I had the old Celestron, Ultima 2000, and it had the flat mirror on the primary mirror, and it would cause the kind of like the coloration on the edges of the photographs.
Oh yeah.
Yeah. So, and now we're the new HD edge like what I have now. You don't have that issue. How that design is.
Yep.
So it is better quality in the way that they have improved on that. Still Celestron. I stayed with Celestron because that's what I like.
Yeah.
Anyway.
Well, that's what we're doing for the next telescope. We're going Celestron. This is Meade. This telescope is the only one in the entire world that's been converted to run at this fast of a photographic speed. So it is a prototype. It is a true prototype. And Starizona down in Tucson will tell you all about. We'll tell you that, you know.
Oh yeah. And
Yeah.
I like it. I like what it does, and I'm sure I'll like the new one.
Oh.
It'll be doing different things. I know different technique, but
Oh yeah.
still be getting amazing shots that
Oh
normally
yeah.
would take all night to get.
Yeah, no, it's still gonna be doing a great job. I want to say hi to Railroad Engineer. How you doing? He says, whenever I watch Sky Tour live stream, the song "Faith of the Heart" plays in my head. Aha, that's from Enterprise, the show Enterprise. Trust me, you're not the only one that has that song going through their head. Hey, Desert Dweller, how you doing? Fantasy, what's up, brother? Good to see you.
And hi to Fantasy, and hi to Cindy Murphy that was in here earlier. I don't know if she,
I said
I don't
hi
see
to her.
the chat.
I said
Yeah,
hi to
but
her before.
I didn't get to though.
Well, I say hi. You're the one that just has to say what you want to see, and we're showing you stuff. All right, cool. Now you can say hi, of course.
All right. Yeah, hi to everyone in chat that I missed, because I don't have the YouTube chat up today. 'Cause I'm
Okay.
watching on Skype, that's why. So,
Yeah, so you can see now that it's starting to come in. You can see that there's some tremendous clouds up here, too, of detailed objects. And there is
does that have
another
a
stellar
different angle
nursery
on
right
it?
there.
On that?
There's hold
on
on,
that left
hold
side?
on, hold on.
Oh.
There's a stellar nursery right here that we can see. There's another one here. You can see there's a little beautiful one there. There's one right here too, which is showing up, and I might be able to show that a little better. And then there's one at the top, which I really want to show you. So I just gotta do this. Hold on. Let me just drop this a little. All right. There's a beautiful nebula and OB association, O and B stars up here.
Oh, yeah.
Uh-huh. And there is... This is a nebula up here. It's just, we have to give it a little more time to come in. It's really, really nice. Maybe
That's cool.
maybe we can see it better if I actually turn off the enhancement.
I was going to say on the left side, it looks like there's a little, like it goes up. You know, like on the skateboard, on the back of the skateboard, you got a little lift there on the left side. And I didn't know if I was seeing that right or if it's the way
You're
that I
talking
see it
about
on,
right here?
right on the, yeah, and then back down to the center of it, it looks like there's an angle
So
there.
like this?
Yeah.
Yeah,
And it's at
actually,
an angle.
yeah, I'd have to look at the pictures. I don't believe that that's a real angle, but it could be. Could
Okay.
be.
I didn't know if I was seeing it wrong or if it was actually that way.
No, I don't think you're seeing it wrong. Okay, let's go down to that enhancement 2. Okay. So yeah, if you notice, it's looking really pretty. And let's go back to what we did before. We'll take it off the dock here, and drop it down, and we'll actually get rid of our telescope. And I didn't want to do that's what I wanted. Okay. All right, and now we can actually enlarge that a little bit and just hang out with the beautiful galaxy for a few. So now you can see it in its glory. You can see there's more stuff going out here. So the galaxy is pretty large. It's really large.
Now here's a question for you. If you had a choice of Starfleet starships to go around the universe, which one would you pick?
That's a really interesting question that I've never pondered.
There's only one, you know,
It's named Enterprise.
and it doesn't have an A after it, as Scotty once said. A, B, C, or D.
Hey, NCC 1701, sir. Yep.
So you'd want the original Enterprise, or would you want like say Enterprise D on the Next Generation?
Well, it's more advanced, you know. You know what I mean? It's definitely more advanced, you know. And I'm not sure I would like a Captain Kirk. Okay? I would prefer a Jean-Luc Picard. Make it so #1. I mean,
Or the Voyager model that can actually land on the surface.
yeah, I know, but I'm not sure I like Janeway.
Oh, come on, I liked her.
No. It's like, Mr. Tuvok, bring me my cigarettes.
I knew I could get doing voices. I knew it.
Yeah, her voice was so annoying to me. I mean, Kate Mulgrew's a great actress, but I didn't like her as Janeway. I couldn't get into it. I'll say there was one show, though, that I really did like. And it was Deep Space Nine. As silly as it sounds, I don't like the Ferengi. I didn't like the whole Quark's bar thing, you know. Okay. But I liked it for the central meeting place of alien life that came in. I kind of liked that. Odo was weird, okay, a shapeshifter, but the concept was interesting. The best part about that show was actually the theme song. And but still, I admit I did like it. I'm gonna kick up the detail here just to see what else is here. As you can see, the Andromeda Galaxy continues out of our view. It doesn't end here.
Oh,
It
wow.
looks green.
Yeah, I know.
Yeah,
The
kind of
color
has
is
green tint.
color's
Yeah.
off just a little bit. I'm gonna see if I can make it stop looking like Saurian brandy.
Now, here's another good question for you. If you had a medical emergency, what doctor would you want? Of the
Please state the
Starfleet?
nature of your medical emergency.
EMS, whatever you called them, right?
Yes, I'm your EMS hologram. Doctor, get off my ship, Janeway. Yeah. I gotta shift the green a little bit, Daryl.
Should be more tan or golden, right?
No, I gotta just get this just right.
I could tell a funny story about Star Trek Voyager, but it's off color.
Oh,
And
go ahead, tell it. Go ahead
No.
and tell
Hey,
it.
I
Ronald,
can't.
that's not your stream.
not in
Oh.
polite company.
Okay, don't tell it then.
No, Ronald, we are a 501c3 organization, so we do have to be careful. And
Family.
we are G-rated the whole time. I mean, sometimes Daisy and Zoe have their cousin in watching, okay? And
Yeah.
I'm not going to say things that are off color ever.
No, I understand. I
I know
understand
you
that.
do. I know you do, you know. And that's why
Isabella's here.
That's why Daryl says what he says. Hello, Izabela. Daryl knows that we can't do that stuff either. Hi, Isabella. We both said that
I
at the
try
same
not
time.
to. I try to behave too.
Oh,
Well, nice.
it's a funny. I'll tell you when we're off the air. So I'm sure some people in chat would find it funny, and a lot of people would not find it funny. So
Right.
better not to say it.
No,
All
it's
right.
fine.
Fair enough.
Okay, so
Say hi, Isabella.
I did already.
We did.
Well, say it again.
Hi, Isabella.
Hi, Izabella.
Yeah. Isabella is from Sofia, Bulgaria, and she's actually amazing. She's a tremendous artist. She's responsible for the beginning video. The song is sung by Rebecca Renfro-Borneman in Florida, and The Universe is Calling You is our theme song, and we thank Rebecca tremendously for that, and her husband Dan, good friends. And she composited some of our best imagery into that beginning 4-minute video. And we do that 4-minute video so people have time to come in and hang out and get ready
Oh, yeah.
as we start to do our evening. Yep. So I just want to make that clear. Now we're still on overload here. We're still hyper processing this side, but here you can see this nebula now up here. And you can see there's one inside this hot OB association. Now, if you look down here, you'll see one that's decidedly bluish. That's probably a supernova remnant out in there, or it could be a tight cluster of hot young stars. I do not know yet. That's something I have to look at. All right, so we have captured more than enough here, so we're going to come back. I'm
really
going to
see the amplifier noise now too.
Oh yeah. Once I get that dark, that'll be gone. It won't even be there anymore. I'm really looking forward to that. Okay, let's bring the telescope back. Move that over. Okay.
Still going to grab M110?
I am. Okay. So now we're still in the Andromeda Galaxy, so we're going to save this. And we're going to save it exactly as seen. Okay. So now for people getting the raw images, I'll show you this is what you're going to get. This is what's out there right now. Okay, this is the image that's out there. Okay. So you get that just like you see it. And that's the free image that you can download. And where can you download it? You go to skytourlive.org right there, and you can find it up there and download it and enjoy it. It's a freebie for you.
Nice.
Yep. But Ronald, because of your patronage, you're going to get the fully processed mosaic of the two sides of the image and everything. Okay.
Wow.
So now that we've saved it, I'm going to get out of here and go hunting for Measure 110. All right, and so to see Measure 110, we just have to head to the west now and move the telescope to the west. There we go.
Maya Leon in chat says she was in an episode of Star Trek Next Generation.
Really?
Encounter at Farpoint.
Oh, yeah.
Oh.
Maya, I think you told us that one time. I sort of remember that.
What did you, who was her character, though?
I think she was I think she was actually an extra. If I recall,
okay.
she was an extra. But she'll tell us. That was very cool. Encounter at Farpoint was the first Star Trek Next Generation episode.
And nothing personal, Maya, but I thought that was an incredibly lame episode.
Yeah, but I would participate in it if I had the chance.
Oh, yeah, sure.
That's really good.
Next Generation, especially the first season or so, they had a lot of really lame episodes. Something changed when they did, was it the last episode of the first season? The one with the little crawling, half scorpion looking bugs from outer space that were burrowing into people's necks and trying to take over the Federation and Starfleet. Remember that?
I do remember
Yeah.
that.
The guy's head exploded.
I remember that, yeah. He was in a
That
chair.
was so bad that the BBC banned Star Trek Next Generation, or banned that episode. Banned that episode from being shown for many years.
Right, because it was apparently so gory. If only people knew how those effects were done. Oh my gosh.
Yeah.
I had to do the visual effects of that before. Go ahead, Daryl. I'm sorry.
Well, my point was that something seemed to change with Next Generation after that episode. It was like Roddenberry had a wake-up call or something, and that really changed the tenor of the show, I thought.
Yeah. Okay, so here's Measure 110. So we're going to start an exposure. This doesn't require a lot of exposure, but just to do the same as before, we're going to do 25 seconds here. And to be complete, we should probably do the lower right so you have a full square. Yeah, no, I'm not kidding. I think that's probably a good idea. Okay, so now we can go into our live stack and remove the last image. That's showing way more than we need to see there. Okay, we've got the ultra processing here on. We're going to turn that off. So here comes the first image of Measure 110. It should be right there. Here it is. And there's a Starlink satellite, probably.
Mm-hmm.
We'll have to see it. Depends how long that is.
I saw those on the Stellarium when I was watching.
Yeah, it's actually, that is a Starlink because it was a 25-second shot. It's also on a diagonal. All right, so now as you look at this, you're going to start to see some detail inside of this galaxy. Typically, elliptical galaxies, for some reason, have no additional gas that's ionized that we ever see, no neutral hydrogen. And now what we see is that many of them don't have any dust either that's visible, right? However, the James Webb has done something miraculous when it looks at some of the elliptical galaxies really far away, with redshifts greater than 10. A redshift is the amount of movement with distance that we see. Distant galaxies are moving away from us at higher and higher speeds. If you imagine how the universe is expanding, imagine blowing up a balloon till it's about, like, say, this big, okay, and putting black dots on it, okay? You put black dots on it, and you blow it up. And as you blow it up, all those black dots are moving away from every other black dot. As the plastic expands, every black dot is moving away from every other black dot. And that's actually what we see in the universe. It's a great analogy for how the universe is expanding. It's only in 3D that you have to understand it's happening. So it's not just on the surface of the balloon, it's all throughout the balloon. So it's expanding in all directions. And because it's actually accelerating as it's expanding, that was the mysterious thing that we have not been able to figure out, why that's actually happening. So the concept arose, well, if there is some form of energy out there that is a repulsive force that pushes everything away from everything else, then maybe that could explain it. And sure enough, it fits the observation. But is it really there? Only time will tell. That, of course, is called dark energy. Not dark matter, dark energy. So let's see if we can get some more detail here.
What was interesting was Amanda did one of her first videos she did on YouTube was the balloon example.
Yeah, she did a star. It was Sky Tour shorts or Sky Tour stories or something like that.
And she had the red balloon, and she had the blew it up a little bit, drew the dots on there, and then she blew it up a little bit more.
And she took my analogy and actually put it to life, and she saw it because I've done it before in front of people. I've done talks obviously in astronomy for decades, and so I spent a lot of time trying to impart to people how the universe is expanding. And before we even knew anything about dark energy, I use this as an example to show how things actually expand in the universe.
One of the funnest things I remember seeing you do, Marc, was at Bill's when we had the tornado time that time, right? We were waiting for the power to come on, and you had toilet paper all the time for planet Earth.
And that's when Bill dropped 1 billion years on the floor on the ground.
I thought it was Eric that Eric was helping you. I thought.
Well, Eric was on one side, Bill was on the other, and Bill
And
Bill dropped 1 billion years of time. He changed evolution. Holy crap! Yes.
That was funny though.
Yeah.
That was so darn funny.
Hey, Lubo in China says I did 10-minute astronomy talk yesterday. Tell us about that. What'd you do? And Marianne is here. Marianne is watching from Benson, Arizona. Yeah.
You got TV out there, or you got internet out there in Benson?
Yeah, she does. Here, look at this now. Okay, see this? Now you can clearly see that there is a dust pattern in here. A nice, you can see a dust lane and everything. And if I actually, I think we're color corrected. I'm going to now just do this. See where it goes. Yeah, look. You can see the dust lane. It's right here. And then you see another right here. So this is, Messier 110 is a galaxy that actually shows some detail, unlike most other ellipticals. Now, here's something about ellipticals, too, that I was getting to, but I didn't finish. And that is that we talk about how fast galaxies distant from us move. The farther away they are, the faster they're moving away from us. That was a find from Edwin Hubble. And so he had a parameter to determine that. It was called redshift. Okay? And the redshift calculation, don't worry about that. But understand this, that when you get a redshift above the number 10, it's a very distant galaxy moving very fast away from us, okay? And it turns out that galaxies with a redshift above 10 that are elliptical, like this, when looked at by the James Webb, were remarkable. They were showing that they actually had spiral arms in many cases, but they were not visible in regular light. In other words, visible light like you see with your eyes. They were only visible in the far infrared. So what that tells me is that it's possible that spiral arms are involved in some of these elliptical galaxies, and they're really spiral galaxies, but we're calling them ellipticals because they present to us with just the stellar nucleus, okay? Yet they have the structure associated with them. I'm not saying this one. This one doesn't have a redshift of 10, okay? This one is only 2.5 or so million light years away. It's not billions of light years away like these others, okay? So it's pretty interesting. Pretty interesting, you know?
So now how far away is that to compare, like, the Andromeda Galaxy between the two? How close are they?
I don't know how far they are actually from each other, but they are associated with it. They are a group of galaxies that are orbiting each other. So those small galaxies are probably, orbiting the galaxy in some manner.
Michael H. asked that question a moment ago.
Did?
Yes, my answer was they're satellite galaxies of Andromeda, just like the Magellanic Clouds are satellites of the Milky Way galaxy, and they're a couple 100,000 light years away. So,
yeah, and
they're still gravitationally bound to the galaxy.
Yeah, we also have a dwarf galaxy around the Milky Way as well.
Okay. Now, on the theory of the Big Bang, how is the formation of galaxies compared to, say, just plain old stars?
Well, you have to ask Sheldon. Finally got it. Okay.
Yeah, it took me
Big
a
Bang
second.
Theory. Yeah. Ask your question one more time. Hi, Gladys.
How does the process of the creation work? Do the galaxies form on their own outside of the stars, or are the stars there and then the galaxies? How does it work?
It's
a tough question.
No, it's not. Why did I not understand your question?
Good.
You're asking me about tell me more. What do you mean by the stars? Tell me about that.
Okay, so when the Big Bang happened,
Yes.
all the energy went out. If we're going to accept that as the theory, okay? It all went out at once from one energy point.
Yes.
Okay? And then all of a sudden you got stars, and all of a sudden you have galaxies. But now the galaxies are sometimes much older than the local stars in the area.
Where did you hear that?
The Big Bang didn't happen at one point. The Big Bang happened everywhere.
Oh, okay.
Yeah,
It was universal.
Yeah, I remember there were stages to it, okay? Now, the first thing that happened was the universe, after the explosion of the Big Bang occurred, the universe was opaque. And that was because it was too hot for there to be atoms. There was just these high energy elementary particles running around, and they made the plasma, and it made the universe opaque. Okay? So, kind of like the sun is opaque to us. We can't see into it, right, because there's plasma in the way. But as the universe cooled down, then we're able to see that we can start to see some transparency occurring because of the fact that atoms were able to form. And so the electrons and protons would combine to make atoms of mostly hydrogen. And that actually caused the universe to become quite a bit more transparent very quickly. I say quickly, over 100,000 or so years. And when it became more transparent, then the hydrogen gas would undoubtedly collect and cool, and we would form stars. And those stars would form into galaxies, because once you start accreting out in the middle of nowhere, this matter, it's going to keep on coming in from all over the place. And so many stars would form and then form families together of stars, which became galaxies effectively. And that happened at a very large scale. And then, of course, within the galaxies and within the star systems that were formed, you had accretion disks of material around those stars, and many of those formed planets as well, along with the stars. In fact, there's more planets than there are stars in the universe.
Mm-hmm. Okay.
Yeah.
So like say our sun, for instance, the Milky Way galaxy was formed. Then our sun was formed afterwards, or at the same time?
It was all about. First of all, our sun is 4.5 billion years old. The galaxy is going to be a little older, most likely.
Yeah.
The galaxy probably has been here for quite a number of billions of years. All right. But our sun formed at a particular point. There's a sliding window of stellar formation in a galaxy. We're seeing stars just forming now, and we see the results of stars just forming now using James Webb and other instruments. We see things we've talked about on our radio show called Herbig-Haro objects. These are objects where there's young protostars that are just about to wink on and start doing nuclear fusion for the first time. And we also see stars that have died, in their novae, supernovae, and regular planetary nebula star death. So it's a sliding window. So where along the whole beginning of the universe did we form? Well, that's actually a very good question. I don't know the exact answer to that, but I'm sure Daryl can figure out, and he's probably looking it up now, when the sun formed relative to the galaxy. But we could kind of estimate based on knowing something about the siblings that we started with, okay? Because we see stars that form in clusters, and we formed in a cluster as well. But for a while, we were the only one of the same type of star. Not G stars, I mean stars with the exact same chemical composition. Like a fingerprint. It identifies a person uniquely, right? Well, what just happened here? That's weird.
What happened?
Mark,
Yeah?
happy birthday to you. Happy birthday to you. Happy birthday from everybody. Happy birthday to you.
Was that somebody in chat?
Yes.
Is it Mark's birthday?
October
In
17th.
3 days.
Yes.
In case we don't see him on the 17th.
Okay,
so
well, yeah.
So happy birthday to you now, Pard.
There you
Well,
go. Happy birthday.
thank you guys. I'm humbled. I did have the birthday celebration tonight, but I didn't actually feel like I needed to crow about it. But thank you so much. That's very kind. Yeah. I couldn't tell what Daryl was doing, and then he just starts, and And he sang a song. That's pretty cool. Thank you, Daryl.
Yeah. I was thinking he was
Happy
singing it to
birthday.
the show or
Thank you.
something.
We're old.
Ah, well. All right, we're saving this, Ronald, and you get all the detail in Measure 110 there for you.
Wonderful.
And by the way, this detail eluded us with the other camera. We couldn't see it. We could barely tell. See this dust lane right here?
Yeah.
Okay. Well, there's another one out here. See it?
Mm-hmm.
We never saw these before. We never saw
All we
this
saw was
detail
light.
in here. We
All
just
we
saw
was
the
the light.
right, and there was a little hint of a potential dust lane. We never saw all this additional detail in here. You see that, Daryl? This
I like
is
that.
really much more
Yeah.
detailed than we've ever seen.
Uh-huh.
I'm really, really happy with that. Okay, we're gonna save this, and then we're gonna save it exactly as seen. And then, Ronald, just to be complete, we're gonna go down to the lower left and do that section too. Okay.
Okay.
All right, so we're gonna go do that as well. You missed a comment, I think, from Izabela before. She said, "Ronald, your mosaic looks fantastic." She said.
Oh, wonderful.
Oh yeah.
Thank you, Izabela.
Oh yeah. She's really
I
good
know
about
she's-
that.
She spent a lot of time on getting everything just right for everybody to get
yes,
it.
She does. Okay, I'm gonna go here and go down to 20% so we can see. Well, that's a little too small. All right, what I'm gonna do is bring us to here so we can actually head eastward. All
I
right.
think on my Patreon you have my email that you can send that link to that I can get that.
Yeah, I'll send you the Dropbox and stuff.
Yeah.
Say
Rhiannon.
thank you to Rhiannon.
Rhiannon. Wow, thank you. That is so sweet of you. That is nice, Rhiannon. Thank you. And I guess I'm going to see you on October 28th, right? Or no, 27th? I believe. I think Rhiannon is coming up here to do filming. Yeah. Rhiannon, tell everybody about the movie, because I think it's fascinating. I agree to take part in it because it was really such a fascinating story about Tom Reed's experience.
Oh yeah.
Yeah.
Okay.
Tom Reed's a good friend.
Yep.
All right, so we're gonna come down here.
I know Dom.
I know you do. And he knows you too, even though he may not want to.
Oh no.
I'm kidding. Yeah, we mess with Ronald, but we only make fun of the people we really like.
No, the first time I met Commander Cobra, you remember what happened?
I remember that was at Pine Bush at their.
Well, no, we were at Bill's driveway when we were getting soda out of the car.
Yeah, but that was for the Pine Bush conference.
Yeah. And
Yeah. You can tell that story.
One 2-liter. That's when I drank a whole lot of 2 liters, which everyone knew about that.
Yeah.
I cut back quite a bit, though. Believe it or not, I have cut back quite a bit.
Well, you used to drink
so-
3 2-liter bottles a day, Ronald. That was a real overkill.
And so I got it down to probably 1 now, so that's doing good. So
Meaning 1 2-liter bottle.
1 2-liter for a whole day compared to 3 and 4 or whatever.
Do you know,
And
Ronald,
anyway,
I don't go through a 2-liter bottle of soda in a month.
but remember, mine was a habit that I've grown used to, and I didn't think anything about it. So
I know.
you're blind to that situation until you're faced with some questions as to what you need to do.
That's
And
right.
so then anyway,
2 liters of what?
yeah,
Diet
2 liters
Coke.
of Diet Coke. Yeah,
Wow.
A day.
yeah,
Well,
yeah.
At least it wasn't Pepsi.
Ha!
But anyway, what happened was dropped the 2 liter and it broke open all over Commander Culver's, probably his pair of shoes that were more than everything I had on, you know.
And Ronald, when that happened, Ronald said, "Oh no, never mind your pants and your shoes, Commander Cobra. I lost a 2-liter bottle of soda."
That's right. Now I got to go back to the store.
Oh
No.
my gosh.
No, he was fine. He was laughing about it. He was a pretty good guy too.
Yeah, Commander
He
Cobra
was,
was a host on the KGRA show, Commander Cobra show, and we became really good friends as well. And he's a really nice person, nice guy, and we ended up spending a lot of time together. And let's see what Rhiannon did. Rhiannon answer. Inducted a documentary about RH. Tom Reed, September 1, 1969 UFO incident. Yep. That's fantastic.
Now, will that be available to watch anytime?
It better be, or it's not worth doing.
No, I mean, is there a streaming platform that it's on?
Rhiannon?
Like DGRA or?
Rhiannon, please answer that for Ronald.
I can't see
Ronald is. I'll answer it for her. I'll let you know. Ronald is our guest tonight as one of our Patreon subscribers. Higher tier Patreon subscribers. This is his night, so he wanted an Andromeda Galaxy. So we're doing a very high-end image of the Andromeda Galaxy for him. And this will be available to other people too, but you'd have to become a Patreon subscriber to get the high-end process shot. But you can get all these shots that we're taking here for free. These are free. Marianne Robb says, Ronald is my hero. But then she laughs
Thank
afterwards.
you, Marianne.
Well, she laughs.
Yeah, right.
So I'm not sure if she meant it.
All right. Well, I'll laugh back. How about that?
Cindy Murphy says, my son, sister, mother, and daughter all in October. Birthdays? Holy cow.
Wow.
That's pretty cool, Cindy. Except for Cindy. She's a March baby, she says. Okay.
Oh, okay.
Daryl, thank you for putting up the link.
Sure.
Oh, Marianne says she meant it. She likes your laugh.
Oh, there you go.
See, there it is.
Yeah.
It's like we don't even have to make a joke. We just have to say, hey, Ronald, laugh.
That's right. And I laugh.
See, there it is. Yeah. We're doing the lower left quadrant now of your image, Ronald, so we'll take that out there. This is beautiful red star here. Let's go see.
What did you call me first? Marc, when you first, one of the first times you saw me at Bill's, what did you call me?
I don't remember. Was it?
You don't remember? You called me Robin Williams?
That was me. Yeah, that's right. I called you Robin Williams.
Everybody else called me that.
Yeah, you look like Robin Williams. You really do.
I got that square jaw. I got the square chin.
Yeah, well, you actually have the look of Robin Williams. You actually look like Robin Williams. Okay. This star, as we're looking at here, is E.G. Andromeda. That's this bright star right here. E.G. Andromeda. Let's go see what it's about. It looks sort of red, and it should, because it's a giant. It's an M2.4 Roman numeral 3 luminosity class.
Oh, wow. So if our sun was an M, we'd be in trouble.
Yeah, I mean, Yeah. So this star, this star here, this star has stopped doing nuclear hydrogen fusion. Okay, it's no longer doing hydrogen fusion. All right, and its distance is 2,188 light years from us. So that's pretty far for a star to be so bright. So obviously it's a big star. Luminosity of a star is determined by its diameter, and of course the color is determined by the temperature. So low temperature, because the star is so big, the outer layers are cooler, but the temperature in the center is still millions of degrees. But the outer layers so far away are cooler. So we don't know what this started as, what it started life as, but it could have started life as a very different type of star, like Betelgeuse, for instance. It's a red star now, right? But it's a red supergiant, and so it's going to be classified in the M range, right, as a red supergiant, say. But it started life all the way at the opposite end of that chart, in the O range. It was a hot blue star when it first started fusing hydrogen into helium, that ran out in just 1,000,000 years or so, maybe a little longer, and it began to swell as it went through its life cycles, and it went up to a red giant, started fusing helium, then it went to another supergiant again, which is where it is now, and it's pulsating, making what are called thermal pulses, and those thermal pulses slough off outer stuff around the outside of the star that become dust and sometimes obscure the star, which is why we think Betelgeuse was dimming so precipitously over the last year or so, or 2 years ago, when it started dimming, and it's starting to come back, so that cloud has drifted away to reveal the star again. But that's all stuff coming from the star. Yeah, Betelgeuse is... I hope it explodes in our lifetime. I'd love to see Betelgeuse blow up.
Now, will this red star here, will it explode or will it collapse?
It depends on the mass. So we have to look at the mass of this particular star to know for sure. And that's something that we can do.
And then our sun, now, our sun will expand to a red giant, but it's not going to explode.
Correct.
Right?
Correct.
It's just going to collapse, and it's going to be, I don't know, kind of
white
like,
dwarf.
almost like, yeah.
No, it'll become a white dwarf.
Maybe a ring, will be like a ring nebula or something like that?
Maybe. It may send a nebula around us. Most likely it's going to.
Okay.
Yeah.
But it's not going to be too much of a big deal, though, as far as big explosion and going everywhere. Okay.
No, it's going to just slough off its outer layers. And those outer layers are going to be pretty hot. So most likely the star itself will expand to fill and swallow up Mercury and Venus and possibly Earth. So,
oh boy.
Yeah, but the sloughed off layers long before that will boil off our atmosphere and our oceans and destroy life here. So we will become Krypton.
Okay, I don't want to be here for that.
No, I don't think that anyone would, and we won't, because by then it'll happen in about 4.5 billion years. So I think by then we'll be okay. We'll be on our way somewhere else.
Yeah. So I ended up getting a new car, not to change subjects, but...
No, please do. Let me hear about your car.
Got a new car. I got a GMC Acadia 2021
Okay.
all-wheel drive, SOT model all-wheel drive. Has, a little dial I can switch to different types of all-wheel drive.
Okay.
And anyway, it has a push-button start, and I keep trying to grab my key. My whole life I always had a key, right? So
Yeah.
I always get into the car. I try to get the key and put it in the ignition. There's no ignition there, and no center shifter. It's a push button or pull button, for the gears.
Yeah.
And it's like, where's my gear shift thing at?
Is that what you're going to drive to Pine Bush next year?
Oh yeah, that's what I drove to Gettysburg last year.
Okay.
July. So, well, yeah, I'll have that next year to Pine Bush. Yeah.
All right. I just want to mention. I'm sorry. Let me just finish. EG Andromeda here is actually a binary star, and it's actually got a white dwarf orbiting it. So, it's possible that if they're close enough, then that K3 giant, I'm sorry, that M3 giant, could Roman numeral 3, could end up spewing gas onto the surface of the white dwarf. I got to look at how close they are to see if that's possible. And if it does that, then the white dwarf could actually periodically suddenly fuse all that hydrogen on its surface, because it's not doing any fusion now. The white dwarf you cannot see in this image, but it's tied in with this star right here. Okay.
Oh wow.
Yeah, and so it's lost in the glare here, right? It's way inside here, but it could actually suddenly start spontaneous fusion on the surface, and cause a huge brightening of the stellar pair, and that's actually called a nova. All right, and a nova can only occur when you have a binary system like that, where one star is bleeding material onto the surface, and if that material starts to fuse before the mass of the white dwarf reaches that Chandrasekhar limit that Daryl mentions often, then the white dwarf won't explode in a supernova called a Type 1a supernova. Okay, it will actually just go nova, meaning it will fuse in an instant all the hydrogen on its surface that has accumulated, and when that happens, it gets brightened, and then after a little while, let's say a week or so, maybe a few days to a week or so, it dims back down, and it just does that cycle over and over again. However, if enough material bleeds onto the surface of the white dwarf, and it doesn't go supernova or doesn't go nova, then if that mass of the white dwarf plus that new stuff going onto its surface goes past 1.44 solar masses, then the star will suddenly fuse that material, and the star will also explode, and you will get a special type of supernova that can only happen under extremely stringent conditions. And because we know it so well, whenever we see a Type 1a supernova anywhere in the universe, we can figure out the distance to where we're looking. It's a cosmic distance candle. It tells us an awful lot. Yeah. So I'm not sure about this star system, but it could be one of those things. We don't need it because we kind of know the distance to this already, right? But still, it's something that would be interesting. So we've got
Now, when if that goes supernova, then would that be a generation, or would that be a way to generate planets or life?
Depends what's there now. I mean, maybe in every supernova, new elements are being created, and additional elements that were part of the star to begin with are liberated. So they all, to some extent, will seed the universe with new material that could be conducive to life somewhere. Okay? And as that supernova remnant expands, it goes out into the interstellar medium, it becomes diluted, it mixes with other stuff, and maybe there is some dark dust around this star that is going to end up making its way to another location where it may spawn the start of another star formation event, and thus, if enough material collects, it might form a disk of material that forms another star system. So it's possible. All right, Ronald, we just finished your 4 quadrants here. They should be relatively good. Izabela will probably have them all put together before the end of this session, because that's how she is if she wants to do it. So we just save this. I have 30 shots here. I'm going to save it one more time. There we are.
So if you had a ship that you can go anywhere, all right, not necessarily a starship like
Okay.
Starfleet or nothing, just any kind of starship, If you could go anywhere and you could witness anything happening in the universe, and of course money was no object, you just go, and you can go 9 times the speed of light,
That's it?
Whatever the fastest speed is, I don't know.
That's slow.
Anyway, the fastest you can go, whatever that is for your time, when you decide to do this, where would you want to go? What would you want to see?
Well, I guess if you're asking me if I want to go back in time.
Oh, okay.
Yeah. See, at 9 times the speed of light, okay, then instead of 4.3 years to get to Alpha Centauri, we'd get there in just under 6 months. Okay? If we were going 9 times the speed of light. So that's why it's still slow. You're going to be 6 months in a spaceship looking at a star that's getting imperceptibly brighter and brighter until it gets closer. And then you'll see that it's actually 2 stars. And then it gets even closer, and you can actually pick out a third one way far away, Proxima. So 9 times the speed of light is slow. We need something faster. In fact, I will be lecturing about that very thing in Arkansas at the Ozark conference coming up. And it has to do with dimensional travel and how real physics seems to support the possibility. Okay. Tell me your other... Okay, go ahead.
Yeah. I was just gonna mention I was watching a YouTube video about the title of it is "We're on one of these 18 universes,"
Okay.
and he had a grid. He had a grid of different Earths out, different sections,
Yep.
and each universe was like, say you take a piece of paper, and you have a notebook of paper, and they each are their own universe, right?
Yeah.
But yet, you're still, you could be in each one of them almost at the same time. But in our situation, because of our 2D world, we have to travel to each one at each time. You know what I mean? We can't personally be in each one at once, but we can travel to each one fairly quickly by just changing pages.
Yeah, I mean, interesting concept. I mean, if I could go anywhere to see anything, I guess I'd like to go out to the cosmic microwave background and see what the universe behind me looks like from there.
Oh, okay.
Yeah, I'd be interested to see, but I don't want it to take forever to get there because then there'll be time for it to change. I prefer to get out there a different way. Now, okay, Brandon Hill, for instance, puts the warp drive. He's actually talking about the Alcubierre drive. Miguel Alcubierre came up in 1994 with, it's called a tensor, but don't worry about that. And basically, he figured out that you could warp space and travel point to point. So if you have space, a distance of say like this, okay, say this is your distance, and here you're going from here to here, you could actually warp space and bring those 2 points together, step across the little gap, and then unfold it, and now you get all the way to the across the entire place. You go from here to here without traveling through that intervening space. Now that sounds phenomenal, but as he points out, Miguel Alcubierre found that you would need to have a stupendously, colossally improbable amount of energy to create what's called the warp bubble around your ship. And Brandon, thank you for bringing this up because it's perfect time to say it. So, excuse me. That warp bubble would require the energy equivalent of being able to convert the entire planet Jupiter to energy. All right. Now, the mass of Jupiter is, of course, massive. And the equation to figure out how much energy is stored in Jupiter is one you know. It's called E equals mc squared. That's called the mass equivalence formula in more formal circles. And so the mass equivalency of Jupiter's mass will result in a certain amount of energy, and it'll be a lot of energy. But you're also talking about having to do that over and over and over again in order to make more than one warp bubble. That's the energy needed to make the warp bubble. So if you can't make a warp bubble, you can't do this, right? So Brandon mentions that the energy requirements are astronomical, and he's absolutely right, just like we talked about. So I have a feeling, too, that the right way, the only way that this can actually happen is via the process that I've been outlining around the country, and that is through a thing called dimensional travel, but it's not a woo-woo concept. It doesn't live in the physics world that it doesn't yet exist. It lives in the physics to come that we can kind of see. That physics has to do with string theory, too. And in fact, it has to do with what's called Randall-Sundrum 1 variation of string theory. In that, you have 4 dimensions, X, Y, and Z moving through time. All right, Daryl's heard this before, he knows. All right, and then there's a 5th dimension, are out there, and that fifth dimension is a highly warped dimension. If you can get into that dimension, then the whole universe compresses around you and gets smaller. So the distances are shortened to every place you want to go. All right.
Wow.
So the farther in you go, if you go in a little bit, it's this compressed. You get in a lot, and it's like here. So depending on how far into this dimension you go, you can actually say, basically punch out of our 4 dimensions, go in a little bit, and punch back in 4 feet from where you were. And because you have big fancy computers that are driving that process, all you have to say is, I want to go ahead, say 30 feet, all right, at a time, and do that for 10 minutes. So then you just punch out and punch in ahead of where you were. Punch out, punch in ahead of where you were. Punch out, punch in ahead of where you were. In effect, making a straight line of movement. So in other words, alien spacecraft that are here don't even require propulsion. They just need the ability to go into this 5th dimension. And what do you need to do that? Well, over at Lawrence Livermore in California, they've discovered how to make fusion reactions that can sustain themselves. Not bring back more energy than you put in, not yet, but a sustained fusion reaction. Very important, because that's the first step in being able to then get energy back, more than you put in. And then, over across the ocean at CERN, CERN, they discovered a certain type of particle that has very interesting qualities, and they're building an accelerator specifically to study, in part I should say, to study these particular particles. Now, what is that particle that requires you to get into the 5th dimension? It's a particle that kind of lives in that 5th dimension, and it's called the Kaluza-Klein graviton, and that's the particle CERN's investigating. Coincidence? I think not. So, clearly, what CERN is doing and what Lawrence Livermore is doing is a fascinating set of independent inquiry into how to get fusion working and how to get these Kaluza-Klein gravitons to work for us. Now, what do you need to create Kaluza-Klein gravitons? A fusion reactor. And that's what Lawrence Livermore has been working on. So, let's add one more similarity. When you look at UFOs, what shape have UFOs been traditionally, Ronald?
Disc.
Yeah, they've been discs, okay? And triangles now, right? Well,
Yeah.
what shape are particle accelerators?
Probably disc.
Circular. We have a circular run at CERN that's miles around, right? And so you have to understand that these are these ships, if they exist, and I believe they do, these ships, if they exist, are actually giant, or tiny, I should say, particle accelerators. And the outside ring generates these...
Yeah.
they generate these particles that pull them into the 5th dimension, all right? And then they reduce the amount of particles they generate, and they come back to our 4 dimensions. So they punch out and punch in. Now, yet another confirmation or potential confirmation is that if you watch something in our 4 dimensions doing what I've just outlined, what would it do? The ship would seem to change color and flash around a lot, because those ships are generating these particles, these Kaluza-Klein gravitons, which are 10 to the 17th times more powerful than the gravitons holding you to your chair right now. Okay?
Oh, wow.
And so, what are they absorbing? They're actually taking in the Earth gravitons and not allowing them to get to the ship. So the ship becomes gravity-free. However, they're also stealing some of the light that's coming from the object, the UFO, to you. So it'll seem to shimmer and change color and maybe wink out of existence and come back, because those graviton sheath around the whole ship are stealing the light coming from the ship as well. Now,
I like that.
these Kaluza-Klein gravitons, all right, generate micro black holes, and that's how that works. Now you might say, micro black holes? Whoa, wait a minute. But micro black holes evaporate in just a few nanoseconds. So you have to keep a healthy supply of them around your ship, at all times
Yeah.
using your fusion reactor over here that Lawrence Livermore is developing right now. Okay, and that CERN is investigating right now, these Kaluza-Klein particles. It's all coming together, don't you see? Now, I'm an astronomer. That's what I got my degree in. So I understand atmospheric scintillation, which can explain the color-changing stuff of a star on the horizon. I get it, okay? I know that people thinking that something disappears from this spot in the sky and reappears over there is actually the result of the autokinetic effect, where you can't focus on any one object in the sky, in a blank sky, because your eyes are always hunting for stuff and doing this the whole time. Right? You can't look in the sky and find a spot, you know. So that said, I can explain that. I can explain them something vanishing here and reappearing over here as possibly being two different objects, or something that's on the verge of visibility and just moving across the sky just at the edge of your visibility. I get that. All of that is possible, for sure. However, as Avi Loeb, who I've worked with a few times, will say, and I agree with, you can't discount the possibility that Kaluza-Klein gravitons are at play here. You just can't discount the possibility. And that's what's so interesting here.
Yeah.
You know, that's what's interesting.
And I was going to ask about the black hole thing, because you mentioned that at one of your talks at Pine Bush. And I remember that because you talking about where you jump through, you know, each hole or whatever, you wind up in a different location each time, of course.
Yeah, and see, I don't think that wormholes, for instance, or black holes, I don't think that's how we're going to travel. That's actually too volatile, right? We'll never be able to harness that technology in all likelihood. I can give you reasons for that after. But the bottom line is that this dimensional shifting capability is actually rather simple when you consider how we can actually do it. We actually see ways to do that right now. The Alcubierre drive, that's a wonderful thought problem, but it requires still, when Sonny White at EagleWorks Laboratories reworked Miguel Alcubierre's calculations, they found, and by the way, there's your double cluster, haha, okay?
Yeah, I like that.
When Sonny White redid the calculations, he discovered he didn't need to use the energy of Jupiter converted to energy, okay, or the mass equivalent of Jupiter. He found that he could change the geometry of the ship so that the warp bubble could be made by using the mass of a Voyager spacecraft-ish mass. So 10 to the 26 times the difference in Jupiter's mass. So that's a huge reduction and kind of sort of makes it a plausible possibility for the future. But that would allow us, for instance, to go from here to Alpha Centauri, not in the 10 or 12,000 years. It would take now, at the fastest possible speed we can go, but we could do it in 5 days. I mean, when I first heard that, I was like, wow, let's do that. Then I realized 5 days is a long time. So we'd have to really work on that, you know, to make it.
5 days, okay. So now 5 days to get there, 5 days to get back here to normal time. How old would everybody age on Earth?
Only 10 days, because you're not.
Only 10 days.
Yeah, because you're not doing a light speed travel. Okay. That would require a faster than light travel, actually, to go to use some other type of technology that certainly would be science fiction at this point.
So we'd be out of the realm of the general equation then, okay.
Yes, we're totally. This would totally be just a 10-day trip. If you went there, saw it, said, "Oh, there it is. Let's go home," and turned right around, went home. You're right. It would actually be a 10-day trip, and 10 days would elapse on the planet. Okay, because now with the dimensional travel, same thing. Although,
so now if you use that to go to M4, then right?
Yeah.
Which is what 4.5.
Oh, you're talking about Alcubierre, the Alcubierre drive?
Yeah.
Well, you just have to take the distance and figure 4.3 light years for 5 days. Okay, equals however many light years to the thing you want. You know. per x, and then you solve for x, and that tells you roughly how long it's going to take in like a straight proportion. You can kind of do it that way.
I think I put Daryl to sleep with all my talking.
No,
he left.
he's been paying attention in the chat. He's been writing stuff in the chat.
Okay, he left a Skype chat though.
He did?
Or Skype. Yep. Said he left. I don't know.
Oh. Okay, I didn't see it.
He might be tired.
Okay.
Possible. Especially if you're up early watching the eclipse, I guess you would be tired.
I guess so. Yeah.
Well, I was up early playing music, so I don't know. That's not the same thing as watching the eclipse, though.
Yeah.
So, I actually forgot that it was, well, we had clouds, so I didn't really worry about the eclipse too much. But then I realized it was happening, and I got to the NASA site to watch it. They had some pretty good locations here to keep track of. So, yeah, so if you can witness, would you rather witness birth of a star and solar system, or the death of a star?
Oh, absolutely, death of a star.
And safely.
I'd love to watch the death of a star.
Yeah, okay. And then you can evaluate what the process is afterwards. Okay.
Oh yeah.
Got you.
Yep.
Okay.
Great.
Because then you can see the death and new life at the same time, practically, if it's that type of a start.
I agree.
Okay. So now, I asked you this question before about the Crab Nebula. I don't know if that's visible tonight or not. I don't think so. But I asked you if we knew what kind of star that was originally, and I don't think that anyone was able to answer that question.
Yeah.
But we know that it exploded in, 1064 or something like that?
Yeah, 1054 AD.
Yeah, and the Chinese were the one that actually discovered it. So if I remember right.
You're right. That's correct.
And that was something we could see in the daytime, if I remember right. I mean, we can't now. But
no, we can't. They saw it in the daytime. they noted a new star. Yes.
And then now, when the Betelgeuse goes...
Betelgeuse?
Yeah, Betelgeuse. Yeah. I don't want to say that 3 times, so...
Please don't.
Especially not this weekend, with Friday the 13th and everything. That'd be terrible.
Oh, I guess it is Friday the 13th.
It was yesterday, yeah.
Yeah.
But anyway, it's too close to be saying that today.
Yeah.
But, yeah, so that went... Then, what was I going to ask now?
I do not know.
Well, we would see it, daytime. Will we see that in the daytime?
Yeah.
The red giant?
Oh, yeah.
That's what I was
they
going for.
said that we would see it during the day, yeah.
Okay. Now, another thing that I was going to ask before about the Orion Nebula, we see it like it's all in the same location, or at the same distance, I should say. It's not necessarily the same distance, right? All the stars.
Say that again?
Okay, are all the stars in the Orion constellation, are they all in the same distance to us?
No, it's a three-dimensional universe, so even here you can imagine that the stars are like a big ball, effectively,
Yeah.
Yep.
And then so some appear closer, but others are farther away, but actually they could be all in the same area. It just looks different to us.
Well, yeah, I mean, it's interesting because in terms of, like, when we look at the skies, okay, we look at the stars, okay, on the near side of the cluster, those stars are closer to us. On the far side of the cluster, obviously, they're farther. So we're seeing them all at different times. And those times could be several years apart. That's what's interesting about this.
Yep.
Yeah.
That makes sense. All right.
Yeah.
So how far apart are those two clusters?
There are several light years between them. I can't remember the exact number.
Yet they're interacting with each other like the cluster of galaxies, right?
Yeah.
Same process.
Yeah.
But what's causing them to be attracted to each other? That would be a good question. Why are they a double cluster instead of a singular by themselves?
I'm not sure. That we don't know the nature of how they formed. They might have formed independently, but as we know, some of these stars that are red giants in here show that the cluster, and they are part of that cluster, are in fact part of that cluster, part of the double cluster.
Hmm.
Yeah.
Okay. All right, that's interesting.
Yeah.
Now I think the if we got time for one last one.
Sure. What do you want to do?
I'm sounding like you almost. Oh, one more, just one more.
Just one
Come
more.
on.
Yeah.
I was thinking M13.
Let's go see where it is.
If that's high enough up.
Let's go see where that is.
Or you can say nope. No, we'll have to do that next time.
Mm-hmm. Well, actually, M13 was going to be way over here, if there at all.
Is it too far?
It's right
the other
there.
way?
Yeah, it's almost to the horizon at this point.
Oh, okay. We can wait. We can
Yeah.
wait for that for next time.
Well, you may wait a season.
Okay, wait till springtime, I guess.
You may have to. Yeah.
Okay. All right.
Yep.
Well, I'm sure I'll have another one by then.
Yeah.
So, yeah, no, I enjoy doing the Patreon thing. It's easy to do. I recommend anybody that can possibly donate to, help out. And Marc does this basically, out of his kind heart. I'm sure you could be doing many other things. Like maybe sleeping. But anyway, but no, I think to show appreciation, definitely send some donations.
Yeah.
It doesn't hurt that much, really. You got it for one day instead of wasting it on whatever. Send it to something good.
Yeah. Well, I know that you felt like this was worth it, and I was really happy you have.
Yeah.
Yeah. Yeah.
But no, I believe in what you're doing, and like I said, you're here every night out of your own kindness and your heart. Of course, that's what you love doing, is teaching anyway. And so a lot of people that come to the streams to watch, they're expecting to learn. Not that all of us have the memory ability to remember half what we hear, but anyway, we're getting there. So
Yeah.
it's but you keep us entertained at the same time. Gives us some kind of direction as to what we need to know.
Mm-hmm.
And that's what's nice about
Well,
that.
I'm glad that you appreciate it, Ronald. Because look at
Otherwise,
this. This is live,
Yeah.
and this is happening right now as we speak.
Yeah.
The universe live in real time. Hey, luckily we don't have to do a mosaic of this. All we have to do is take some good shots for you.
Yeah. There you go. I was going to say, otherwise we'd have to get our own books. We'd have to get our own telescopes, which I have one.
Yes, you do.
And we'd have to spend the time where I'm getting into the colder weather now, which I'm not going to want to be outside at all.
Yeah, yeah.
And what was weird was last year at this time, 5 years ago, it said on my Facebook page.
Yep.
5 years ago on October 14th, we had snow here.
Okay.
So now last year, the last week of September, we had snow. Okay.
Yeah.
and it was about maybe 16 inches, but it didn't last very long. It was still kind of warm, so it melted away.
Mm-hmm.
And then we had a snow in the later part of October, I think, and in November we were stuck in snow for till the middle of April. We had the last snow, so that's 7 months that we had snow.
Yeah.
So I'm not going to go outside with a telescope when it's like that.
Yeah. I just want to take a moment to say hi to Gladys and Rascally Rabbit, who's here. Greg O'Brien, hey man, how you doing? JSCO, what's up? And Old School, what's going on?
All right.
I heard from Old School earlier in a chat, a message, so it was very kind to send that. Thank you. Excellent. So we are doing this guy here. We have enough of these double cluster, so we're gonna save this.
That'll make another nice picture. That double cluster.
This is gonna be, yeah, this is beautiful. And there's no wind out there tonight, so the guiding is really.
Well, I was glad
pretty
for that because
nice.
I was worried about it was Thursday night when you had the wind problem, right?
Yes.
And you tried, but it wasn't cooperating with you.
Yeah, I don't mind shutting down, and in fact, it makes the most sense to shut down when that happens. Yeah, because I am really unhappy about doing that kind of thing. I don't want to see any problems with a telescope with the wind. All right, let's see here.
One last one, and we can.
I know. I mean,
it's
it's like just one more, just one more, just one more. Yeah.
I'm not helping you any. I'm egging you on.
You are. Yep. Okay. Okay, I've done that. Let's see. It's really a toss-up here. Trying to find one that I want to. I know I had one that I wanted you to see. Maybe what we'll do, let's see. I bet you we can look at it now. It wasn't high enough to see before, really. But it certainly is now. So why don't we look at the Triangulum Galaxy, since we just did the Andromeda Galaxy.
Oh, yeah.
Would you like to see the
Yeah, we
Triangulum
mentioned
Galaxy?
it, right? Yeah.
All right.
Yeah, we mentioned that before, too.
All right. We're going to save this one more time. Look at those beautiful stars.
Yeah.
Okay. We'll save it and then save exactly as seen. And then we're going to get out of this and go back to our night vision mode so we can watch it come in. There we are. And they look beautiful, you know. So I'm gonna actually, I'm gonna drop this down to. Oops, hold on. Drop this down to say 25%. Okay, and now we come back here, and we've selected Triangulum Galaxy. We're gonna head there now. Okay, now. And plus it makes pretty art pictures.
Oh, yeah. Remember when our friend Jennifer would say, "Oh, she used to like the clock drive sound on the old system."
Oh yeah, Jennifer Serene Nico. She liked to hear the telescope movement. I wish.
Yeah.
Well, we might get. That's actually important to hear too. So I have to. I might want to actually get something to allow us to hear that again.
Yeah.
All right. All right. So there is the galaxy. I'm gonna just go south a little bit more for a second.
Now I can see it. I can see the cloud
The
part
nucleus.
of it there.
Yeah, that's the central nucleus. Yeah. And
Which it looks like a cloud to me, you know. So
it does. But here we go. We're gonna say searching, and once we start to see numbers.
I mean, when you're Macer, the astronomer in the 1600s, how are you gonna know to zoom in on that?
You don't. In fact, you don't even know what it is as an astronomer in the 1600s. You just think it's.
He was in the
cloud.
1600s, wasn't he? In 1600s, yeah.
Charles
And so
Messier, 1700s.
he was a lot of the ones he was doing he was searching for comets, or was he searching for galaxies?
Yes, he was
Which one it?
searching for comets. You're right.
Okay, and then he found most of the galaxies, figuring out they were
Yep.
galaxies instead of comets, which was pretty amazing.
All right, so we're gonna clear this. Ronald, I have to. Will you excuse me for a moment? I gotta do a quick errand. I'll be right back.
All right.
All right. So you can sit there and talk for a minute, but I will return in just a moment.
Oh yeah. All right. Well, I don't know what to talk about now. We can talk about Marc. No, we won't talk about Marc. No, I think we can talk about when I met Marc first time. I think it was 17 or 16. 16 or 17. Can't remember. 16, I think. That was first Pine Bush. Anyway, yeah, I've known Marc a little bit before that, though, on a YouTube channel. So, it was nice to meet him in person. Always a pleasure to talk to and learn from. And then, watch him do his talks is pretty amazing. And then when I see him like on the History Channel, it's like, I know that guy. Pretty fun. Yeah. So dimensional travel, you know, I was talking about that before, but I was talking more of the mental state. And at nighttime when you go to sleep, I believe everyone travels to somewhere. That's my idea. But I call it nothing to do with any kind of preference. I call it transdimensional, which is you're in a trance, you're sleeping. Transdimensional, and I actually looked that word up. And I just talking about your dimensional travel. I was talking about that before on my show, and mine's a little bit more the mental state of things, where you can send yourself to anywhere you want to go. You know.
I experimented with that years ago, and I had a moderate level of success. And at one point, I seemed to be able to leave my body, and it literally scared the crap out of me. I never did it again.
Right.
I
exactly.
I couldn't get back in,
but
and it was
I
really
was
frightening.
I was talking about the dimensional travel in the sense that I believe that we have a parallel us on another Earth, just like ours, right? And when we have that Freud situation where we have what the term is the tip of the tongue, you know, where we just forget something in the middle of a conversation, and just like I just did when I was talking about Beetlejuice, you know.
Yeah.
I couldn't remember the name or what I was talking about that. And then I was trying to remember, we could see it in the daytime. That's what I was talking about. Right. So anyway, when you have that tip of the tongue scenario, okay, what happens is your other self switches places with you. And then, of course, your other self is coming into the middle of the conversation. And then, what are you talking about? What? Trying to catch up, right? And then you're over there on the other planet trying to catch up to whatever they were talking about, okay? And then you come back and now I remember what I was saying, right? And so I was talking to a friend of mine. He's 76 years old. He's one of the guys here in town.
Mm-hmm.
One of the 349 people in town here. He lives here, and we were at a function in the town at a breakfast or whatever. And he forgot what he was saying. And I said, "See, there you go. That's your other self. Your other self has what you're gonna say." And he just kind of laughed at me. Well, remember that when you forget something, it's your other self that has it. Just wait a second, it'll come back.
Okay, that's one way to look at it. I'm not on that camp, but you have a right to, research the different avenues, every avenue you want. Hey, Prow, how you doing? Prow just joined us.
All right, hi, Prow.
Yeah. Yeah. So it's possible. It's very possible.
I mean, there's no way to prove it. There's no way to prove it. There's no real way to disprove it.
Yeah.
The only thing that's common is that you have a forgetful moment that you don't know what happened to your thought.
Yeah.
That's all.
Well, in this moment, that's actually not a forgetful moment, but an unforgettable moment. Let's
Right.
let's drop our window out, and let's actually remove our telescope. Let's bring this over, okay, and let's zoom in on this, and just take a tour of Messier 33. This is the Triangulum Galaxy in Messier 33. It's called. Now, there's a few things to notice in this galaxy, and I'll show you. If you notice, that guy right there, that's called NGC 604. It's actually a large nebula, a stellar nursery in another galaxy, 2.7 million light years away. Okay, there's another one right here, and another one right there, and another one down here. There are so many of them throughout this galaxy. They have their own, in another galaxy, they have their own object names. Also, in a very interesting twist, we see supernova remnants, like that green one right there. That's actually a supernova remnant right there. Right? It's
Wow.
green. We're going to zoom in on it. There's another one right here. Look at that guy. All right? That's a supernova remnant as well. Right there. Sorry. Right there. Okay? And there's another one down here, right here. So you look in these galaxies and you look for amazing stuff. And you have the nucleus of older stars, and then out here you have these spiral arms full of the young, hot stars. And they are just, these spiral arms, it's those spiral arms, okay, where you actually see stars being formed. That's where they're formed, is in the spiral arms. It's really,
Wow.
yeah, it's really cool.
That's where we are in the Milky Way. We're in the outer arm of the Milky Way.
Yeah, actually, if we think of this as the Milky Way, we would be right about here. Okay?
Yeah.
And Orion would be just about here. We actually would be in a part of the Milky Way right near Orion. And it makes for a really interesting relationship with our Milky Way, right? With our galaxy.
Yeah.
Yeah. So it's pretty cool.
Yeah.
So we'll let this come in. This is a beautiful image. We've got 16 images stacked so far. And as you see, the stars are just beautiful. We focused already, but let's zoom in now. Right? Because I want to show you some more things. Okay? Look at this gorgeous nebula. You can see tendrils and spikes in it. It's just beautiful. Look at that. All right? And now this supernova remnant up here, let's pull this down a little. This supernova remnant right here, you can see has wisps and so forth. If you remember,
Oh yeah.
in our galaxy, we have the Veiled Nebula in Cygnus. And it's a supernova
Oh, yeah.
remnant. It's a giant set of arcs, right? And they're three-dimensional, don't forget. So they're kind of coming off in all directions. But we only see it as a two-dimensional portrayal on the sky. We don't know how far into the sky and out of the sky they come.
Right.
We have to do more studies to figure that out. I'm sure some have been done. And then we have another remnant right here. Look at this. This one is making this large wisp around this central area. Okay, so only if we were to be able to capture this with more detail. So let me. So in other words, I was just reading a message I saw from Izabela, which is concerning. I'll have to check it out. But still, we can see this quite nicely. And because tonight doesn't have any wind, we're getting some beautiful shots. This will be probably the best Messier 33 we've ever taken. Here's another beautiful nebula location. Look at that, with all that detail in there. Now, this is detail that would be lost to us. We would not see this, except with this camera we can. So that's really interesting. And look at the detail in this thing. I'm going to just, right now, with 21 stacked, I'm actually going to save it. I got to name it first. We're going to call this M33 Triangulum Galaxy. And Triangulum is the name of the constellation it's in. All right, so now we're going to save, and then save it exactly as seen. Okay. All right. Now, let's see if we can do some processing to pull out more detail, shall we? I like doing live processing with you because this is pretty cool. So let's race up right near the peak of that curve. If we go past it, we'll start losing data. So that's about as far up as we can go. And now, let's pull this up here just to put it in the middle. Look at all this detail. This is really spectacular. Holy cow. That's a galaxy 2.7 million light years away. You're seeing it 2.7 million years ago. Think about what was happening on Earth when the light that left that galaxy started on its journey here. And for 2.7 million years, it's been traveling through the cosmos to reach our telescope. Now, if I'll say it this way, if no one else is looking at this galaxy right now, then all the photons coming to our eye that made a 2.7 million mile trip we get lost to history and never get seen. But we're capturing, at least for a few minutes now, we're capturing 10 minutes and 25 seconds worth, as it says right here, of photons. And that's 2.7 million years ago, these photons left. So only those few lucky ones made it into our camera to be recorded for history. All the rest are going to be lost to time because it's possible, but not highly probable, that we're the only ones looking at Messier 33 right now in the sky. But there could be studies going on, and maybe there's like 400 people across the United States and the world that will be looking at Messier 33 to do studies. There's ongoing studies all the time. So what do you think of that, Ronald?
I like it.
Yeah.
I'm looking at the fine detail that's there.
Yeah, it's got a lot, and you're going to see even more. You know, look at that. There's another remnant that we've never seen. Yeah.
And that's one thing I can say about the new camera and the way that you got it set up with the F2 compared to the F10 or whatever it is.
Yeah. F8.
I think my Celestia on the HD Edge 8-inch, I think that's an F10 if I remember right. So.
Yep.
Still a good system.
Absolutely. Absolutely is.
And I did get the battery to replace it, but I never figured out if I have to. Do I have to take off the orange ring at the top of the arm to get that battery out, or can I just loosen that and turn the cover to reach the battery?
Not sure.
Not
sure. I'd have to look at it to see. I'm not sure, Ronald. I'll have to look at your particular telescope.
Yeah, it's a Celestia on HD Edge, or what do they call that? What is the name of it? I got it put in storage right now because it was going to be winter, so I put it away.
Oh, yeah, that's when you bring it out, because you got to see Orion.
I know, but it's, like I said, it's going to be too cold out here.
Yeah. Hello, Bonnie, Anahata77. Hello there. I missed your arrival, so I apologize. So this is Messier 33, and it's really looking pretty. I'm going to save it again.
Dust lanes in there.
Lots of dust. Okay, we're going to save it exactly
as seen. So that's where the accumulation of planets or new stars?
Well, it's in that dust. You know, the life originates in the dark dust. Okay?
Okay.
Because that's where all the elements and the material to make planets will be. It won't be in the hydrogen gas. Okay? It'll be where all the dust is. So that's where elements like potassium and phosphorus and sulfur and nitrogen will be from all the supernovae that release these elements to interstellar medium, and they'll be mixed in with the dust, and you might get nitrogen ices forming on the surface of these dust grains. And it's only small amounts, but when you add up the absolutely mind-numbing quantities of these dust grains that are out there, then you will get a chance to see or get a much better feeling for just how populous these dust clouds are, and they can actually tremendously easily make star systems very easily, and stellar nurseries like this one. There's a stellar nursery right there. We saw the big one right here. There's another one right here.
Yep.
See that? Okay.
Yeah.
Down here, there's another one right here. And there's a whole host of smaller ones out here.
Yeah, the first
Okay.
time I didn't see your cursor when you were first telling me about that, but I knew where you were talking about.
Right.
So I kind of knew where you were talking about. It was when you mentioned the green one and the, different
Yeah.
ones. And so I was able to figure out where you were, but I didn't see your cursor at all.
Yeah.
So that was some reason it was
Yeah.
not on the screen.
Yeah.
Uh-oh.
No, don't worry about it. I have to make a adjustment here. I want to bring something up here to help us see this better. All right, so 1 second. I'm going to make this visible, and I'm going to give it back to you in a second. Don't worry about it. Let's do this.
That would be a really strange picture for the wall.
Yes, it would. It would. This is what we want. There we go. Okay. All right. So now, over here, we're seeing this, and I gotta now bring you back. So I will do that. If I can just figure out where we are. Here we are. Okay. 1 second here, Ronald. All right. All right, 1 second. I'll bring it back in just a second. And you get this right here. There you go. Okay.
All right.
I had to give Ronald his screen back so he could see this. And, all right, in just a second here. Let me just bring this down.
Now, are all those, see those stars on a line on the bottom, about 6 o'clock?
Where?
In the middle, on the bottom, in the center, towards
Right
the
there?
center. No,
Oh.
up in the galaxy part. Yeah, they're all 4 in a row.
Oh, you're talking about, I know what you're
They
talking
look like
about.
a belt. Yeah, they look like a belt.
Right
Are
here.
they all in the same line and distance, or is that just according to our sight?
These stars might be in our galaxy, but in fact, every star you see that's an actual star is in our galaxy. Our galaxy, the stars are here, and Messier 33 is way the heck out here. So you're seeing
Okay.
stars through, you're seeing Messier 33 through a veil of our own stars.
All right,
Okay,
that
so,
makes sense.
Yeah, that's what's going on. I gotta bring my telescope back here for a minute.
It's interesting how it kind of lines up with it, though. It looks like it's part of its
Yeah,
thing.
yeah. I mean, but that star looks like it's in it too, but it's not. That's in our galaxy.
Right.
There's no stars that big in another galaxy.
Right. If it was that big, we'd be in trouble.
Yeah, I would say that you.
We wouldn't. We'd have, we'd have math figured out wrong.
Yes, absolutely. All right, so that's where we want to be, right there. Okay.
Unless it was the new math we're talking about, then maybe we get away with it.
Yeah. Okay, so we have done quite a lot, and these are good. We're gonna save it and save exactly a scene. This will make a phenomenal piece. Izabela did do the full mosaic of Measure 32 or 31 for you, and I'll show you that after we get off, or
Okay.
after we actually do the work to process it for you, so you'll see it.
I think all of them that we looked at tonight will make a good picture.
Oh yes,
Good picture
this is
for the
gonna
wall.
be really, really pretty. Yeah, this one stands a chance to really be a standout shot. Here's another
Yep.
stellar nursery right here. Another one right here. Another one right here. Another one right there. A little one. Okay. A large family of them right here. Of course, the big one there. It just is. This galaxy has, and there's a little one right there, and there. I mean, I gotta stop because they're everywhere.
There could be life there right now. We wouldn't even know it.
That's correct. That's correct. So that
And what
this,
if they
this
are-
is beautiful.
There's some of the ships that we see. Maybe they come from there and they figured out how to get here.
Yeah, well, they probably got here the way that we talked about it.
Yeah.
I
like the way-
interdimensional travel.
Yeah, that makes a lot of sense, actually. I think it's actually more simple than we want to make it out to be. We tend
No.
to overthink things.
No, we tend to overthink, yes, but yes, this requires a lot of thinking. So there's
But
the
you know what I
name.
mean? Like you know what I mean? Like we
Yeah.
overthink it, you know?
Yeah.
So,
So this is
and it,
just, I mean, I can't stop looking at this. This is really nice. Holy cow.
now compare it. I know it's a different shape of a galaxy. This is more towards our shape of a galaxy with the spiral design, correct?
Mm-hmm.
In comparison to the city Andromeda, which is that a spiral? That's a spiral too, but it's a little bit
Tighter.
more.
It's more
Yeah.
tight. This one is known in the old parlance as an S for spiral and a little C for open arms. Okay. Well, now those letters are changed. They made a little change, so it's capital S, capital A, and then little C. Okay. And
Yeah.
that's the spiral designation for this. C means loose. See, the arms are not really, they kind of fly out like it's a pinwheel flying
Yeah.
apart. Andromeda is a cohesive one. Our galaxy is cohesive. Our spiral arms are tightly wound, more so than this one for sure. But let's see. Let's do this. Let's actually zoom in on this now. Interesting to think that we're peering 2.7 million light years away. Look at these dark lanes. These are all going to be beautiful. Look at this gorgeous area right here. This might be a supernova remnant tied to a hydrogen emission region too, because look at this greenish thing right there. That's probably a supernova remnant.
Is this into our past? This is into our past, right?
By 2.7 million years, yes.
Oh,
So
wow.
all of this galaxy looks slightly different in some way.
So we're time traveling right now.
We are. We're time travelers, but we can only go back in time. I mean, we
Right.
look at the moon, we're seeing it as it was a second ago, right? I mean, so obviously,
Yeah.
and the sun 8 minutes ago. So,
Right.
now let's see where the processing wants to rest with this. So it's going to push it a little bit. And let's see what the color correction wants to do. Color correction looks good. Now, I could push this a little bit more like that. And then move this dark level all the way to the peak. And this is about as dark as you'd want to get it. All right. Like that. This glow over here, this is the amplifier glow. And that thing I told you about before, the dark frame, is going to fix that when I go out there.
Yeah.
Wow, nice. Okay. Last save with 54 frames. We've actually been doing this for 22 minutes. Save exactly as seen. And there we are. Well, there
Nice.
you go, Ronald. And as a bonus, you can have this Galaxy 2 fully processed.
Nice.
Right?
All right, you're hired then. Okay.
Well, I would guess I am, but that's okay. Well, let's see. All right, well, guys, that was good. We had a fun night. This was Ronald's night. He's one of our biggest Patreon guys. We made this night for him, and as a result, you get some cool pictures too. They go up there, and if you want to join our Patreon, you go to the Patreon page and you can see exactly what we have to offer. I think that you'll find that for what you get, we offer an awful lot, so it's pretty cool. I do want to thank the existing patrons that we have. Okay, John P, Izabela M, Ali B, Chief McCyber, Vera C, someone named Ronald T, whoever the hell that is. Martin W, Raymond B, Cindy M, Susan W, Diane H, and JSCO77, who is in the chat tonight, along with some of these others. Very nice of you to be with us and to support us. We could always use, we do need more people. We actually have internet to pay for, a new site to pay for, and everything. But I'm really pleased that you guys could join us tonight anyway. So I hope you will have a good evening. We're going to sign off for now. It's 1:30 a.m. for me right now.
12:30 for me.
I have a few things to do before we go. I have to close everything up, and that's what I will do. But anyway, I hope you guys have a good night, and we will thank you very much for being here, Ronald.
Thank you, Mark, and thank you, Daryl. I know he's already went to sleep, but thank you anyway.
Okay.
And thank you to everyone in chat that I didn't get to say hi to because I don't see chat. So I was trying to focus on what you were showing.
Yeah. I want to address a question by Old School. He said, can you get rid of the stars and show just the galaxy? As a matter of fact, Old School, that's exactly what we do. We actually take the stars out of nebulae and take them out of every object we ever photograph and just process the nebula or the galaxy alone, because we don't want to process the stars too, because it's a separate layer. And we put them in as a separate layer over the gas clouds and the dark nebula, so that we can process only the nebula or the galaxy, and that gives us a way to show you that. And I'll show some of that imagery. So that's the other thing too. As a Patreon subscriber, a higher tier, you can have the starless imagery as well that's been processed, so you can see. For instance, you should see what the Pillars of Creation image looks like without stars in it. You see all those convolutions of gas and dust, and it literally looks like a three-dimensional portrait you can jump into. It's really beautiful.
Yeah.
So hopefully you'll
cool.
consider joining us, because that is something for the Patreon members of the higher tier. But you know what? Because it costs us time and money to actually process those. So if you want to do that and you want to be part of it, we'd love to have you. And you see some really cool stuff. All right. Anyway, this was great.
It's not too bad. It's not too bad at all. It's pretty easy.
Yeah. Well, yeah. Ronald's been a Patreon subscriber for quite some time now.
Yeah.
So
yeah.
here is the last image that we took coming up. Let me see if it'll. There it is. That's got this up there. Let me reduce that so you can see just the galaxy. So that's what we just took a picture of, and that's in our buffer. We saved it. It's now on the. It's up on the server for you to download just like this. So please do. And we will see you on the next SkyTour live stream. I hope you guys had a good time. It seems like we had a lot of.
I did.
You got your night, brother. Yeah.
This was fun. Fun that I waited for the night when it was no wind.
Yeah, you got no wind going on, so you literally had the best possibility, the best possible, best possible night. You're right. You
Good.
know,
We'll do this. We'll do this again one of these days. And
yeah.
also, if you want, on a Friday night when you're not too busy, you can join me on my show. And
Yeah. Tell
if you're
everybody where
not,
that is.
you go to ERRT Radio YouTube channel, my channel, of course, ERRT Radio YouTube, and it's
And
on Friday
that's
night.
he said ERRT Radio, ERRT Radio.
Yeah,
Yeah,
and
tell him where to find that channel though, because he didn't say where to find it.
it's on YouTube.
Oh, it's on YouTube. Okay.
Yeah, you just hit the search bar and hit ERRT Radio, and you'll
Okay.
find it. I'm the
Very
only
good.
one there.
All right.
And you can look at my website, errtradio.com, ERRTradio.com. And then we have a music station. Well, I call it my music station. My audio station only is on Mixlr, mixlr.com/ERRT-radio. And sign up there, follow me there. And then you can listen to all my shows. We've got different shows on there. A lot of music in the morning time. And then pretty much I do most of my shows are now on YouTube. Actually, my interview shows and things like that.
Okay.
I have another friend of mine, Maureen and Anthony, does Dimensions of Supernatural on Thursday night. This next week, they're coming up on their 1-year anniversary, which is hard to do.
Mhm.
It's hard to have a show weekly and last a whole year, and yet they've done it. They've made it to 1 year. And
Wow.
Maureen has done other shows that she's created and done, and they haven't lasted very long, but still she's been busy doing other stuff. But she's done other shows for me on my channel, but she's done this Thursday night show every single week with her and Anthony, Maureen Grudzinski and Anthony Simonelli.
All right.
But
Very cool.
that's pretty good. We get all the paranormal people watching them all the time, so we get a lot of viewers on that one.
Excellent.
But yeah, and then I got over 1,000 videos, I think, total on my channel, and I got
Okay.
720 subscribers, I think.
Okay. So let's build his subscribers up, guys.
Yeah, we're trying to get to that magical number. Apparently 1,000 or something that happens. I don't know what. But apparently you get all kinds of interesting free stuff you can do.
Yeah.
So,
All right.
but
Well.
hopefully we can get there soon.
Yeah. Since you're still here, what I'm gonna do is, this is the telescope out in the building, and
Oh, yeah.
I parked it and shut it off. So now what I can do is close the building now. And
See all that? You can hear the motor going.
Yeah. Yeah. You'll notice that there was a star up there, bright object, probably Jupiter.
Yeah.
Yep.
Now, on my audio side, though, I have over 102,000 total listens. That's 102,000 total. I mean, people listen
Wow.
to my audio side. 102,000. Actually, a little bit more than that. But anyway,
Cool.
that's a lot. That's a lot.
Well, Ronald, thank you so much. It was a pleasure having you here, and
Thank you.
we look forward to doing this all again.
Oh yeah, and I'll have more choices to look at, so you won't have to figure them out yourself.
Good. And by the way, Maya, I don't know if you answered whether you were an extra or not on the. Maybe you did. I'll have to check the chat and make. I don't need you to go say it all over again. Sorry. Anyway, I hope you guys have a good night, and we will talk to you again soon. Say good night, Ronald.
All right, good night, everybody in chat, and thank you for listening to us, and see you next time.
Awesome. All right, guys, we will see you later on the flip side. So we'll talk to you later on. Bye-bye.